Was heißt das?
Fucking ist okay, awesome.
Hey, ihr müsst es positiv sehen. Ja?
Haben wir ein Bild?
Wir freuen uns einfach.
Gut.
Ja, und wir noch nicht, aber wir haben es ins Internet geschafft.
Achso, aber Bild hast du auch. SDI liegt schon bei dir.
Ja, seid nur cool. Ihr seid auf einer Konferenz mit Hightech, leider mit kleinen oder lauter Chemiekleinigkeiten. Ja, voll gut. like generally spreading wisdom to the world. And with that,
Okay, good morning. Hello. I'm Megan Knight for those of you who might not know me. And this is...
you know me. I'm the guy with the hat. No, I'm Josef.
And he's the Yocto Project Community Manager, along with myself, the Advocacy Manager. We're just so happy to have you all here with us today in sunny, dry Vienna. Thank you for showing up on such a beautiful day after all of the rain we had. And with that, we will go ahead and get started. The schedule link was added to Sketch yesterday afternoon. So if you've got the Sketch saved for this session today, you should be able to click just directly on the link from the session in Sketch. If not, you can go right here to this link. That's the schedule today. You can see the slides if speakers have submitted those. This is the general flow for today. There's a coffee machine outside. It'll be accessible all day long. We will have some snacks and treats. Did someone just call like a bird?
It was a pretty mighty bird.
Oh, wow. Oh, my. Okay, so yes, we'll provide some snacks at the coffee breaks, and then the lunch will just wander until we find some sort of sandwich cart. We have a surprise announcement. While we couldn't get the Chromebook to work, we somehow managed to acquire a live stream. So we are now streaming live on YouTube, so please tell your friends if they were unable to join today and want to hear what's going on in the room. Live stream's running right now. That's the link. And we are also recording today. So big thank you to Josef for the equipment and Thomas for managing the equipment all day. Just a quick round of applause there. Thank you so much for your contribution. Okay, so advocacy. I would be silly if I didn't take a moment to talk about it. What do we do? Well, between you and I, we have the most fun. But on a more specific level, we are responsible for kind of going out into the public and making sure people know about Yocto Project far and wide, right? So these are a few pictures from previous really boring times in the Yocto Project advocacy group. With Dev Day last year in Prague, Embedded World this year in Nuremberg. And I just really want to make sure that you all are aware that this is a thing, that either you or people within your organization can participate. You do not need to be a member to participate in advocacy. So if your company is not currently a Yocto Project member, that is not a reason to not participate, if you catch my drift. If you are a member also, in the event that things go to voting within advocacy, which in my 2.5 years has never happened, but in the event that it does, you do get a vote as a member that's a little bit weighted higher than a non-member. That aside, we just get to have fun. So lots of events. You get to put on demos within the booths. We are desperately trying to work out a way to get some more use cases on the website. So if you have use cases that your company may be willing to share publicly, this is one of the other great ways to support the project without really needing to do any active work. Use cases is something that really helps us push membership, which helps fund initiatives and future feature development. So it really helps us show how widely used and accessible Yocto Project is. And we would just really love to feature whatever your use case is and show people what you do with Yocto. Local meetups. So we would love to start, coordinating more local meetups. We unfortunately can't clone ourselves. So while I would love to be in 20 places at once, I would love to see the community doing stuff within their community. So if you have any ideas on how to kind of kickstart or advertise local meetups that are already going on or communities we can highlight and help make sure people are aware of their meetups, we would love to start doing that. So lots of great and fun ways to kind of get involved. The last bit I want to mention is that we are actively working towards producing Yocto Project specific training that is self-led, module-based, and will end in some sort of shiny badge that you can let people know that you're, the smartest of them all when it comes to Yocto Project. Currently, we're working out a plan right now where we would start on some sort of beginner module because it's the most requested, with some sort of, advanced track a year later, and then ending in some sort of certification. I've been talking to embedded communities across multiple verticals, and the struggle is real. No one is changing from embedded Linux anytime soon, and yet the number of qualified applicants for entry-level positions and beyond is dwindling. So we need to do what we can to empower our community, to educate our community, and make education accessible. So that is the goal of this. Hopefully converting some contributors into maintainers and some users into contributors and feeding our healthy developer pipelines. So if you are interested in helping us develop this, or you want to voice your opinion on what you'd like us to not do, that's also really important. So please reach out to the advocacy mailing list. We'd love to hear from you. And with that, I'm going to hand this over to Josef.
Oh, okay. Yeah. Thank you. I guess we can go across this relatively short, because most of you, or I guess some of you, have been to the BOF on Tuesday. Raise your hands. Okay, most of them. So just a real quick one. We are really proud to welcome some new members, like the big ones, that really make us or enable us to do this kind of stuff. First one that we can announce now is Garmin, specifically a very, very prominent gentleman who's doing a lot of crazy stuff in terms of SPDX by the name of Joshua who is on the payroll of Garmin. So first, welcome Garmin. Then another one on the same level, welcome Boeing, a very prominent gentleman called Chuck Wolber, who's doing a lot of stuff in the security area. So welcome Boeing, welcome our new platinums. I'm just gonna be real quick. So and there's two non-platinums also who have joined just recently. It's Peridio and Ambition. Ambition does something with cars. Peridio does something not with cars, something with AI. As far as I'm concerned, I don't know the details because I'm just a clown up here. Yeah, thank you. Besides that, like I said, I'm going real quick. Cool stuff. You know, this is the in-person event, so it's actually the only real in-person gathering of Yocto affine people that we have on this planet at the moment. We encourage you to change it, but use the day because it is your opportunity to connect with your peers. And the next, not exactly as exciting, but also very, very important opportunity to connect is the virtual summit that we will have early December. Hopefully we'll get out the CFP real soon, and all of you, please submit and tell us what you're doing, learning, breaking, or just spare everybody else the pain that you suffered if you did something wrong. Tell us what you did wrong. Yeah. And with that, just some minor housekeeping. You know, SCARTCAP is out. It's the current LTS. It will be maintained until 2028. StyHead 5.1 is coming up. I would say the two shiny new features that it has is Unpackdir, which fixes some crazy problems around source code organization. I even don't understand it. And SPDX 3, which has just recently been announced, and we already have support for it exactly in StyHead, thanks to Joshua's tireless efforts in doing things that are beyond our understanding.
And I was just notified last night by LF Research that they consider Yocto project one of the top 2 CRA compliant, CRA ready projects out of every project in the Linux Foundation. So I just want to give a huge shout out to Josh Watt because we would not be able to do this without him.
Yeah, SPDX.
It's a big deal.
It is a big deal. With that, everybody, have fun. Remember, we try to be inclusive. We try to be embracing to every kind of person, non-person, entity, spirit, whatever is out there. Be kind to each other. Insults or spoken violence are only acceptable if agreed upon by either Megan or me. And every other kind of violence or harassment or whatever is not accepted. I mean that, okay? And with that, up to you, folks.
Let's welcome our first speaker.
Who is the first speaker, anyway? We need to grab that stuff. Yeah, that's good, because then we can take that one away.
Please work, please work, please work. That's a step in the right direction. Bear with. Now, what direction is that? There we go. Bump. I've lost my pointer. It's fair. Right. Right, so hi. This talk is called Writing a Usable BSP, and it's I'm Ross Burton, Principal Software Engineer or Yocto Engineer at ARM in the software distros group, where we mainly work on upstream distros, making them epic on ARM. I should also quickly point out we're hiring, so if anyone wants a job, come and go to careers.arm.com. I mainly work upstream on Yocto, just trying to make it awesome. My colleague has a focus on ARM itself, so I'm in a really lucky position there. But this is a talk for both authors of BSPs and people who use BSPs in anger. So if you're writing a BSP, then consider this the beginning of a best practices document, which we need to actually write at some point. And if you're using a BSP and it's frustrating you, then hopefully this will be a bit of backup. So when you need to complain to your vendor, you can say, but they said this. I'm not going to name and shame any particular BSPs because that's not tremendously professional and we might run out of time. But there's going to be time at the end for Q&A because I thought this was a 30-minute slot and it's actually a 40. So hopefully maybe at the end we can vent. So what is a BSP? In Yocto terms, it's a board support package. This is traditionally it's a collection of tools and documentation that vendors would give you when you bought a piece of hardware. It's a very old term. Yocto adopted it, and it means a very specific thing in Yocto. It's what you put in machine. This controls the target architecture, any compile flags that need to be used all the time, the file system layout, what image types to use, what kernel and its configuration. Any firmware that needs to be built would be part of the BSP, and fundamental dependencies. So when you're constructing an image, what pieces are actually essential. But a BSP is not a demo. This sounds obvious to people who are trying to build product, but if you're a vendor, a BSP is a demo. And they sort of forget that it's not a demo. They build a testing tool, so it can be used in validation, which makes sense, or it can be a reference distribution, or just a hardware demo, which shows off all the shiny features. So it might have secure boot and hardware accelerated networking or accelerated 3D rendering, which is lovely if you're making something which intersects precisely. If you're not, then you've suddenly got this BSP which wants to pull in Mesa into your machine, which is headless, which is no good. Also, demo software is demo software. I've written plenty of that over the years, less said the better. If you told me in 2007 that SARTO would still be used in 2024, we may have done something differently. It's aging, shall we say. Anyway, Hardware BSP, anyway, there we go. So demo BSPs tend to, in dreamland, look amazing. They can be fantastic and beautiful, but they may not be production ready because once it's good enough, it ships. So they may be a bit more eye-catching, but do you want to base a product on this thing? No. You want something which is a bit more flexible and a bit more controllable. I'm a big fan of Lego, so it shouldn't surprise anyone that I do believe a truly usable BSP should be more like Lego. So that is the absolutely epic Rainbow Unicorn set, which I have on my shelf at home. It's got an amazing main set. It's got 2 secondary sets, with all included in the instructions. And you can build it. It looks great as it is. You can build the alternative sets. They look great. Or you can just throw the instructions away, take the bricks apart, and build something else. Equally epic. No one at Lego sat down and thought, you know what, let's make a set that is a unicorn, but rebuilds as the magical unicorn falcon. BSB should be like this. Flexible building blocks, fully featured example, lots of documentation, but you can customize it, you can rebuild it, and you can build something the vendors never considered. So, what makes a good BSP? I think they should be modular, upstream, and modern. So let's go through these. You should have modular layers. In Yocto terms, the bag of Lego bricks is the BSP layer. And the instruction book is a distro layer. The distro layer is there if you want it, but you don't have to use it. You can just take the bricks and build what you want. There can also be multiple software layers depending on how complicated your system is. So you may have multiple layering to pull in separate pieces. Because Yocto is good at layers. Layers are always the answer. Just have a core layer, which is just for BSP. This only does hardware enabling. It's got the machine definition, the firmware, a sensible kernel. I'd love to say a documented and modular def config would be fantastic. And any hardware enabling for recipes such as Mesa, where you need to customize them slightly. The machine shouldn't be doing anything like pulling OpenGL into every image, which I've seen BSPs do, or test applications into every image, which I've seen BSPs do. Every line in the machine configuration should be either essential or a sensible default, which can be easily changed. Core image base, for example, should just work. And not have any unexpected dependencies. So it's a headless image, just works over the serial line. It shouldn't be pulling in video decoding stacks. Then you can start layering on top. So here we have OE core at the bottom, and then say a Meta Unicorn toolchain layer, which might have some special compilers. I'm kind of inspired by ARM structure here. Meta Unicorn BSP, which is the base BSP for the hardware definitions. And then say, a Meta Unicorn Secure Boot, which is pulling in, saying, if you've got Secure Boot, then it depends on these other layers. And then this is how you customize it for this machine. And then on top of this, a demo layer, which can be the shiny, which customers can use and you can take to trade shows. Because this is all logically structured, customers and users can start at the demo and go, yeah, that looks great, this is what we want, but, and then look at what has happened and just ignore the top sum. So they may want everything but the demo application. They can just rewrite their own distro layer. They may not want secure boots. They can take that out. You can just mix and match the pieces. So they're using the BSP instead of fighting it. Of course, all these layers do need to be maintainable. As the functionality in layers get a bit more complicated, you may want to have layers which have optional dependencies. just quickly say, this can be done with BB files dynamic. Not a lot of people know about this variable because it's a bit niche, but it lets you include recipes in your layers depending on what other layers are present. So hopefully everyone can actually read that. That's an abridged example from metanome, where chunks of the recipes are only passed if the virtualization layer is enabled, you get a dependency on the virtualization tools. And if the security layer is enabled, you get the security recipes. So this lets you have a layer which has optional dependencies, so you don't end up having to pull everything into every build. Just see more examples of how that works. It's in the documentation. Also, with your mountain of layers, always run Yocto check layers. If they pass, you'll be able to get a Yocto project compatible badge, which is good. We're currently working on an improved version of the tests, which are going to be stricter, because we've noticed some BSPs are playing fast and loose with some of the expectations. So I recommend running it now to get ahead of the curve, and over time it will get stricter. And if anyone has any ideas and extra tests, just let us know. Finally, remember to add all these lovely new layers you've written to the BSP, the layer index, layers.openembedded.org. I should have put the address on the screen. It's always worth checking to see what's on there. It's probably worth checking before you start writing a new BSP that someone hasn't beaten you to it, either with just something that happens to have the same name, or maybe you decided to make a Yocto BSP after you released the hardware, and someone else has already done the work for you. It would be awkward and confusing if there were 3 slightly or not so slightly different layers with the same name targeting the same hardware that were different. Just saying that does happen. And while we're talking about layers, I've discovered a BSP that does this. Don't fault Pokey as part of your BSP. That's really frustrating. Just work. All BSPs should just work with plain Pokey or even better, OE core. Pokey is just OE core and bit baked glued together, so they both should just work out of the box. But I've heard there are BSPs which need a forked Pokey to run. Moving on from layers to machines, your machines can also be modular. To start, if there's going to be multiple boards, say you're a silicon vendor and there's going to be multiple boards with the same stock inside, name the machine after what's written on the board instead of the stock, so people can actually find it. When it's written on the board in front of them and then the layer's got the same name, much easier. If you do have multiple machines which share socks, then you can have include files with the common pieces in, and then the machine configuration would just contain the special bits of differences. And if you end up having quite a lot of machines in this situation, you can extend machine overrides. So hopefully everyone's seen the override syntax. In OE core, there's 6 QEMU machines. To save everyone having to write 6 overrides every time, we add an extra override for QEMU all. All the QEMU machines have that override available, so we can just write QEMU all in an override. We also use that in Meta ARM. There's Corestone 1000 FVP and Corestone 1000 NPS. They are the same IP, the same core internally, but there's some very minor differences around the outside. So they need to be 2 separate machines because the firmware is different. So we have an overriding just Corestone 1000 override, which is used almost everywhere, apart from the 2 or 3 places where it's very important to know what your target hardware is. That's very useful. Also, to encourage more modularity in the machine configuration, machine features is essentially free-form text. So here we have my new machine, and it says, oh, I do EFI, I do PCI, I do Wi-Fi. I've also got new hotness and shiny feature. And these can be used across recipes to configure functionality. As an example, MetaArm uses this quite a lot because we have some features which need to be enabled in multiple pieces of firmware and then the kernel and then user space. So this lets us just have one machine feature we can set, everything just works, and then in CI we can toggle it on and off and have different builds testing all the different combinations. It just keeps everything nice and modular and testable. And the final piece of being modular is modular recipes. Use existing ones as much as possible, ideally. If your board is ARM-based, OE Core and MetaArm together will hopefully have all the pieces of low-level recipes you need, from firmware up to the kernel and bootloaders. These are designed to be used by other BSPs. Like in MetaArm, the firmware recipes don't support any hardware. You have to append it with the configuration for your particular board. We do this split in MetaArm, so the recipes are in MetaArm, and then the implementations of what they run on is in MetaArm BSP. So we know it does work, and hopefully other people will use it. This will stop people hopefully stagnating on a version of TFA from 5 years ago. This does mean working with a recent release of the kernel or the TFA and upstreaming the support, but obviously that was going to happen, right? Slightly suspicious face. Yeah, just please work upstream. Don't ship in 2024 a U-boot from 2019 or a 5.2 kernel. It's really best to plan up front that you're going to be upstreaming any relevant hardware changes to the kernel or U-boot or wherever. The longer you sit on them, the harder it will be, and the more bitter your customers get as the recipes get more and more out of date. Consider the implications of shipping an unmaintained kernel to customers who have very strong opinions on security issues. Because the moment they run a CVE tool on a 5.2 kernel and then send you a letter, what are you going to do about these 15,000 CVEs? You don't want to be responsible for checking those. Right, last piece. Be modern. Don't start porting your BSP to the latest Yocto release after it's happened. By the time the BSP is actually shipped, reached your customers, they've imported to it, and then they've released a product, a fair chunk of the LTS window has disappeared already. So we have LTS releases with 4-year cadence, well, 2-year cadence, 4-year support cycle. If it takes a year to actually ship something, then that's a quarter of it gone. So be aware of the release cycle. It's on the wiki. The Starhead release is coming out imminently, hopefully in the next few weeks. And that will just be supported until May, because it's an interim release. The last LTS was Scarf Gap. That came out earlier this year. That's supported till 2028. So shipping something now, which is based on Scarf Gap, means you've got nearly 4 years of support. Shipping something now, based on Kirkstone, you've only got 2. There's only 2 LTS releases at any point in time, so it's not a huge commitment to just actually support both. You don't have to add anything to them once they've shipped, just keep them stable. MetaArm does this. Our older BSPs are less functional than the new ones, but they're stable, they're not changing. And yeah, the interim release is only us around for 7 months until the next one. So if you just keep on track of ideally master, at least the interim releases, then when it comes to the next big release, it's not a massive problem. Finally, listen to your users. Yocto makes it really easy to switch hardware. So keep them happy, and hopefully you won't lose customers. Encourage and embrace a community around your BSP. Happy users are great for advertising and support. So have a mailing list or forums or Discord or whatever, and get involved. You lot are awesome. Actually accept patches. You shouldn't have to say that. Don't have an unmaintained Git repository which gets a dump every 6 months with just update. And any test scripts that you're using internally to approve patches should be public. It's really frustrating when you send a patch to a BSP and they get told, oh, it breaks the tests. So can I run the tests? No. You just have to magically know how to fix them. So yeah, that's not ideal. This is not trivial, but it can be done. I keep on using Metarama as an example because it's mine, so I can. Our test infrastructure is entirely in GitLab CI. So it's not trivial to replicate it, but it can be done if you've got a machine and a GitLab clone. Okay, so actually, because I thought this was a 30-minute slot, that's done. Any questions from anything I raised? Any concerns? Or does anyone want to have group therapy? Has anyone got a really bad BSP that you want to rant about? Or has anyone found a good one? Is there anything else I didn't mention that I should write down and add to a best practices guide? Thank you very much. Any questions? Any comments? Anyone found a good BSP? No. Okay.
Only bad ones.
Only bad ones, yeah. Well, maybe we can work on that. While scribbling this down, I did think this should probably be something that's not some opaque slides unless you're watching. So I will try and turn it into some documentation at some point. It would be amazing if Yocto check layers could validate some of the more obscure cases, but it's some of them are tricky. Like, how do you tell if inappropriate recipes are in? Oh, yes, a question.
Yeah, one thing to consider is also...
Should I have on the microphone?
Oh, wait.
Is this on? Yes.
So one thing to also add to this list of good BSP and bad BSP practices is not to ship your code in the layer. Please put it on a public place somewhere for us to download.
Yes, absolutely. Big Git repos with lots of big layers with lots of source code in is a terrible idea. It makes it very difficult to maintain and develop, so please don't do that.
So a recommendation actually. If you get your layer from like shitty BSP vendor, just strip the recipes you need, right? You don't need to use the BSP layer that is from Krogoth, and just do not stick to the BSP vendor layer if you don't have to. And usually you don't have to. So just take the Linux recipe or the U-boot recipe and put it in your own layer. You don't have to stick with Krogoth or whatever. Just use the latest LTS or even the latest branch from Pocky or whatever.
Yeah, there's... I know of several open source, like community-maintained BSPs, which looked at the vendor BSP and said, that's interesting, but not that. And yeah, just rebuilt it from scratch, taking the upstream kernel and any important patches and just a minimal re-implementation. Yeah, absolutely. Some vendor BSPs are so suboptimal that it's easier just to do your own. I have told people this repeatedly as well. Yeah, good point.
So now that I actually provide a vendor BSP, I have questions. So you said that we should not basically provide in the BSP layer some like hardware acceleration for VPU, GPU, that kind of things. So basically my point is, I have pretty recent SoC, and the GPU is only supported with the latest Mesa. But latest Mesa not available in SCARTGAP, for example. But obviously, our customers, they're going to want this. So how do I handle this? Because I don't, like, my opinion is I would not want anyone that is not using our product or not building for our product have our layer in their Yocto build. And now, magically, they have the new update in Mesa, and they wouldn't expect this. I would expect.
Yeah, it's an interesting problem. I suppose this detail I probably skipped is the BSP layer can contain the enabling for stuff like, oh, here's the patches to make Mesa work, or worst case, here's an upgraded Mesa. But don't do something like pull it into every image because you think that's essential. The recipes can be there and enabled, just not necessarily automatically pulled into everything. So I've seen BSPs which just have literally image install append equals Mesa in the BSP machine configuration, or pulling in example demo recipes. It's like sort of not in the machine because it's very hard to undo that. But yeah, it's when you've got new hardware and older releases, it's an interesting problem. But especially if you do try and pass the Yocto compatible test, because then adding a BSP layer and not using it shouldn't change anything. So if you just add an upgraded Mesa to your BSP layer, you have to be careful to guard it somehow, probably with overrides, compatible machines, so that it doesn't just get used. So like if you've got Meta Unicorn with a brand new Mesa, having it enabled in your layers but building a Chemu machine shouldn't use that Mesa. And that will be a fail on the compatibility test. Yeah. Anything else? I think we're done. Excellent. Okay, thank you very much. Hell yes.
Thomas will put you live out for the world. And welcome. Is it Julien or is it Julien?
Julien.
Julien. Welcome, Julien from Bellibre, and who will talk us about rock and maybe even metal things, right?
Yeah, maybe. Thank you. Can you hear me correctly? Yep. Okay, great. So, welcome to this presentation about bblock. We'll try to introduce you this new tool, which will help you to lock your Yocto recipes and save your time. So here is a quick agenda of the presentation. I will do a quick introduction about Bellibre, about me, and about bblock. Then we will see the workflow for Yocto developers and our real life. You know, when you do a small change and Bitbag decide to rebuild everything. Then we will have a look at the locking mechanism in Yocto, and we will see that everything is already there. Then we will talk about bblock, how we can take advantage of the Yocto mechanisms to lock recipes efficiently. And then as a conclusion, I will try to give you some hints and advices on when to use and not to use a bblock. And we will do a quick overview of what will be the next step for bblock. So about Bellibre, it is an open source consultancy company specialized in embedded systems like the Linux kernel, Yocto, U-boot, Zephyr. We are also doing a little bit of hardware design. And as of 2024, so this year, we now have a compiler and toolchain team. We are based in France, in Nice, but we have a global presence all over the world in the UK, Canada, America, Italy, Germany, and more. We are a Linux Foundation member, and we do have a lot of Linux, Yocto, U-boot, Zephyr contributors, and even maintainers. And in case you want to know more about Bellibre, you can just go on the website, bellibre.com. About me, I'm an embedded Linux developer. I'm based in Avignon, France, which is only 2 hours and a half driving from Nice. I didn't know that. I'm an open source lover since I started school, like 10 years ago. And I joined Bellibre in February 2019, so it's like 6 years ago. And if I go more specific about Yocto stuff, I'm a Yocto user since I joined Bellibre, so 6 years ago. And I'm now a regular contributor, since a year. And I mostly contributed on DevTool stuff. And of course, I'm a bblock author and maintainer. So about bblock, it was merged upstream in September 2023. So it is almost 1 year old. It is a new Bitbag tool. It was released first in NaN build, but NaN build not being an LTS. I guess most Yocto user does not know about bblock. So here is a good occasion to present it to you. And now it is part of ScarsGap, which is an LTS, so hopefully more and more people will use it. A maintainer is me. The main job of bblock is to lock tasks and recipes. And for the story, Bugzilla ticket was opened by Richard in 2019, so when I started to use Bitbag as a user. So it was 6 years ago, meaning that the community wanted to have such a tool for a long time. And it was tagged as a newcomer's bug, and it was the first bug I tried to implement. So not a small one. So now, let's talk about the real life of Yocto developers and our workflow. So as Yocto developers, what we do is we do some changes to recipe, and then we start Bitbag. And then Bitbags will compute everything. And most of the time, you know, unless it is a first build, it will be very long. But when you are doing your development, you know, the compilation time will be too small to switch on something else, okay? But it was too long to wait in front of your screen. So what do we do as Yocto developers? We have several options. I'm sure some of you will recognize themselves. We take a break. We have some coffee, maybe a nap. And our break is often longer than the compilation time itself. You can see it. Yeah, I'm not going to judge you, don't worry. And then we do a test. And yeah, before being Yocto developers, we are more regular developers. And as all developers in the world, we never do the right thing in the first place. So we have to do again the changes, and again, and have another nap or another coffee, and that's life, you know. And there is an XKCD comics I really like, and I'm pretty much sure you all know it. It describes very, yeah, it's very our life as Yocto developers, you know. Okay, not code is not compiling, but bitbake is running, but yeah, that's life. So I wanted to show you how we can use bblock in our daily life. So I want to have this real-life example. I want to customize my Python banner on my interpreter. So I want to add, welcome to the awesome Bailey Python interpreter. So that's something fancy and not too hard. So for that, I will use this environment, a Poky distribution, QEMU x86, machine, core image minimal, lightest scarce gap release. And the only tweak I did to the default configuration was to add a Python 3 to my image. And then I started my development. I added this small patch, to Python 3 source code, which is just adding a printf statement, so nothing really hard. And I added this patch to Python 3 recipe. And that's it. So one line here, one line to the source code, and just rebuild my image. And 14 minutes later, I was able to run my QEMU interpreter to see my, my awesome Python banner. And here it is. Oh, wait. I just realized I forgot a new line character. And it took me 14 minutes to realize that. And it was 14 minutes because I'm using a big build server. If I tried to do it on my computer, it was like 45 minutes. And obviously more coffee, because I can't use my computer when it's building on it. So yeah, why is it so long to just rebuild and add a small printf like this one, and a shitty one, by the way? So why is it so long? Because the changes I did triggered change in Python 3 recipe, obviously, but also in Python 3 native recipe. And a lot of recipes depend on Python 3 native. And when I decided to rebuild my full image, bitbake decided to rebuild all packages depending on Python 3 native. And yeah, it took a long time. So what if we could have a way to tell bitbake to not rebuild some recipes? I mean, in this example, we can understand that you don't have to rebuild Python 3 native and all packages depending on it just to add a printf in my Python interpreter on the target, right? So that would be awesome if we could do that. So let's have a look at the locking mechanism in Yocto and what is already there. So first, let's talk about task signatures and state. So when you start bitbake, it will compute the signature of all tasks that are needed to build your target. So the signature of a task is a checksum of the task inputs. Inputs of tasks can be the body of the task itself, but also some user variables such as src URI, or maybe some machine variable, or maybe the depending graphs of tasks. So if you modify the do fetch task, it will have to rebuild the do compile, do install, do package, etc., etc. So all are the input of the task. There is a checksum, and this gives you the signature of the tasks. So at startup, it will compute the signature, and it will compare them with the one in state. Obviously, if it's your first build, you don't have state, right? So you will have to compute everything from scratch. But if you already did one, you have S-state, and any difference from the newly computed signature and the one from S-state will cause the task to be rerun. And otherwise, you can use a cached output. And this is great, and it works well for incremental build. You know, when you modify your recipe, and all these recipes does not have any link between them, so you don't want to rebuild this, and this is great. But BitBake decides by itself, and sometimes there is a small link, and you know it is safe to not rebuild all these recipes, so you just want to tell BitBake, okay, don't do this. So how can we do that? How can we force BitBake to use the S-state even if signature change? So as I told you, there is everything in Yocto, and in particular, there are these three variables, variable 1, 2, and 3. I'm sorry, I'm not going to pronounce them because it will be a pain for me and for you, so trust me. So I will name them variable 1, 2, and 3. Variable 1 is the most important one because it is the one that will actually specify the signature you want for a given task of a given package. Variable 2 is the allowed overrides for the variable 1. And it is mainly used to lock signature per architecture. And the third one, which is optional, will control the verbosity in the output when you lock recipes or tasks. Currently, these three variables are not documented yet, and it is part of my to-do list. I'm trying to improve documentation about that. Thank you. So here is an example how we can use variable 1, 2, and 3 to lock a specific task. So here is a do patch task from BC for a Klimuk x86 machine. So here we are, the three variables. But how can we use it in practice? I mean, you're not going to build and compute the signature by yourself, you know. I told you every BitBake and Yocto has everything to do it for us. And in particular, you can use this command, bitbake-S locket6 target, to generate a file that will contain all the signature of all the tasks that needed to build your target. So here is an extract of this file. I built it for BC recipe. You can see that BC depends on AUTOREV package. So we have all the AUTOREV tasks with their signature and BC obviously, and you know, this file is quite long, so just an extract. And there is this wiki page here. You can check to have full information about this command, but unfortunately it is not up to date, and it is also part of my to-do list to update it with more accurate information. I promise I will do it. But BitBake-S has some drawbacks. So first, it is more commonly used to share a full S-state for a complete build. And you have to use it with another tool. This one, I'm not going to pronounce it either. It is documented on the wiki page I showed you before, so you can go and see. The generated file locket.inc must be manually included inside conf. So user has to manually include this file. So typically in its local.conf file. This file can be more about 1,000 lines for a single package, and it is much more if you build it for a complete image. And according to the wiki page I showed you just before, you can use this file to lock a single recipe or even a single task, which is what we want to do, right? But users have to manually extract the line from this file, which is around 1,000 lines, and with variables that are unknown and undocumented. So it's really not user-friendly, right? So here comes bblock to help you in this task. So bblock is here to address some drawback. So first thing to know, it is not a wrapper around BitBake-S. It is a standalone Python script that is using Tinfoil API to talk to Bitbake. It can generate signature for a single package or even a single task, so you won't have this huge 1,000 lines file. It will generate only the signature you want. And for the story, when I upstreamed bblock, it was not possible to extract only one signature from Bitbake. So I added some new API from, and the Tinfoil API accordingly to be able to retrieve only one signature from a single task. Output is written in build.conf bblock.conf file, which is already included in bitbake.conf, so user does not have to manually include the generated file inside its configuration. Everything will be transparent for the user. It is really, really easy to use, as I will show you in a couple of minutes. It is only a single command to run, and everything is done for you. And signatures are also architecture specific, which can be very useful. You know, as for the 3 variable and the wiki page, bblock is not documented yet. So all you have is the help message and hopefully this presentation now. But it is also on my to-do list to add some documentation somewhere. I don't know yet where, but you have the help message right now. As you can see, it is really easy to use, just a space-separated list of recipe to lock, and 3 switch, the task switch if you want to lock a single task, a reset switch if you want to unlock recipes, and a dump switch if you want to dump the generated file. And that's it for now. I hope we will have some more options later in the future. So here is how you can use bblock to lock do compile task from BC. You will see I use a lot BC because it is really easy to type, no typo, and it compiles very quickly. So just run bblock bc and -t do compile. That's it. Takes a few seconds to run. And if you want to look at the generated file, you can use the dump switch. And you can see it's only 4 lines. With variable 3, 2, and 1. And it computed the signature for you. So you just have to run one single command. But how can I be sure that the task is locked? You can trust me, or you can test. You can use -C, or you can update the do compile body of task from BC. And you will now have these 2 new lines. So the first one is a note stating that we have locked tasks from several recipes. Here we have only BC. And the second one says that the do compile signature is computed to be something, but the signature is locked to something else. And at the end, we can see that he attempted to run a lot of tasks, and none was rebuilt, and all succeeded, so nothing was done. If I have time at the end of the presentation, I will try to do a live demo so we can see that in action. If you want to unlock BC, you just have to run bblock -rbc, or if you omit everything, it will unlock all recipes at once. That's pretty convenient. So now let's go back to our Yocto workflow. So we are still Yocto developer, right? So we will still do some change to recipe. But before doing that, now we have a new tool, which is bblock. And before doing any change, we will lock recipes that we know for sure that it is safe to lock. It is important to do it before doing the changes. Then we start Bitbake. And then, obviously, we still have to wait for completion, but it should be faster, right? So you won't have time for another nap or another coffee, I'm sorry. Maybe you will have time to read a quick XKCD comic, but no more. And then you will have to test again. And you know, you are now super Yocto developer, but you are not super developer anyway. So you will still have to do your fix again. I'm sorry. But at least the loop will be faster now. So yeah, we can update this new XKCD. So yeah, you can't legitimately slack off by saying that bblock is now compiling because the time you ask for it, it is already done. So back to my customization of Python banner. So first things I need to do is to lock Python 3 native recipe. So just run bblock Python 3 native. That's it. Then I add this new line character in my patch and start the build again. And it took me only 1.5 minutes to rebuild the full image compared to the 14 minutes before to rebuild the image. And that it's a game changer, sorry. So 1 minute compared to 14. So here it is, my new interpreter with my new line character. So I'm so proud of it. Just took me 1 day, but yeah. So let me try to give you some hints and advice on how to use bblock. So first things I want to highlight is that bblock is intended to be used during development phase. So please don't forget to unlock your recipes before delivering and rebuild everything from scratch. Yeah, this is really important. If you need to share a full estate, you should still use bblock-S. Maybe in the future, this option will be removed from bblock command line and be merged into bblock. But until then, you should use bblock-S to share the full estate. Bblock is right now only used to lock a single recipe or few recipes. You also need to make sure that you really want to lock a recipe. So if you modify a recipe and it rebuilds a lot of stuff, and you don't know why, you may be tempted to lock these recipes, but it may not be a good idea. You should first follow this guide to understand what changed. And yeah, because if bblock rebuilds stuff, it's because there are maybe some good reason to do that. So unless you are pretty much sure it is safe to lock, you should just first follow this guide, and then, if you think it's a good idea, you should lock your recipe. You should also check that if locking a recipe is the correct thing to do. I'm pretty much sure in the audience, some of you noticed that I used bblock for something it was not meant for. I mean, I should have applied my patch only for class target, right? And this would have saved my time recompiling Python 3 native recipes. So I did it on purpose for the fun, but you know, you have so many ways to do stuff in Yocto, so you should choose the correct one. You know, bblock comes with a lot of other tools, and there is this devtool deploy command I really like, which help you to save a lot of time during development phase when you just want to rebuild some packages and deploy it on the target. This is avoiding to rebuild a lot of stuff. But you know, sometimes, unfortunately, some recipes don't build under devtool. And sometimes you just don't have a way to deploy on the target. So bblock can be an alternative to the devtool deploy command, but maybe you can use it also instead of locking recipes. So what's next? I would like to improve output formatting of bblock.conf. Right now, each new signature is added in a new line, like this. So when you lock a full recipe or several recipes, it is really verbose. I would like to sort tasks alphabetically as in bblock-S output. I really want to improve the note warning messages that can be really verbose if you lock several recipes. And add documentation for bblock, but also for these variables. I would like also to find a user-friendly way to use build stat and graph dependency with bblock to directly spot long-running tasks. There is a wiki page to try to investigate build time, and this can be a step forward, you know, to know, okay, this task is really long-running, Can I lock it using bblock? That can be useful. And most important, I really want to have feedback and contributions from you and the community to improve the tool and yeah, use it. Just a word from Richard Purdy about bblock. I see this as a key thing in the project's future. It ties into other pieces like the bitbake setup change, reworking ESDK, and more. It also leads into improving the project's usability. So I do believe that bblock will have an important future for the Yocto project, so I will encourage you to use it and give some feedback. And a last word to conclude this presentation, and before doing my live demo. I see bblock as a kind of modern superhero because it will help Yocto developers, so you, in several ways. So first, obviously, it will help you to save your time by avoiding unnecessary compilation during development phase. But it can also help you to save your job by increasing your productivity and makes your manager happier. Wait for it. It can also save your life by reducing your coffee consumption. But you will also have less naps, so yeah, not sure. And you can also save the planet by reducing energy consumption. So yeah, modern superhero. So in one word, just use it. I still have a couple of minutes, so I would like to try a live demo. Hopefully it will work. Can you see? Or maybe I should increase the... Do you see it, or should I increase it? It's fine? OK. So I prepared two windows here. First one, I'm running with a QEMU x86 machine, and the second one to show you how bblock with lock recipes in architecture-specific way. I have another terminal where I will build for a QEMU ARM machine. I will use BC, as you can imagine. So let's try to build BC first to see if it is already built. So it should be. So nothing will be done. OK, nice. Now let me lock BC. So bblock BC. So a single command. And it takes a few seconds to run. I can dump the generated file using the dump switch, bblock. And here it is. So it is a bit verbose because the screen is small and there are a lot of tasks. But you can see that you have only the BC task and all BC package and all the tasks. And now I will try to change the body of do compile tasks for BC. OK, just me update it with some. I do like to add a printf and echo statement, you know. Hello. And then we'll try to build BC again. And I should see the note and warning messages I show you in the slides. So I have the note now and the warning saying that the new signature is computed to be something, but the signature is actually locked to something else. And you can see that nothing was built and everything is done. And if I look at the bblock file, you can see that it is locking recipes for this architecture. So if I go in the QEMU ARM window and I try to build BC again, it will build BC because it is not locked for this recipe, for this architecture. Sorry. So here it will build the package itself. And now I can also lock bblock BC, and I will just specify the do compile task. But I will lock it for this architecture. You can see it's really quick. And I can dump it again. And I can see the last line. You can see it is locked for a new architecture right now. So if I just remove all the changes I did, let's dash. So nothing is, so I removed the hello statement. And if I rebuild it for this machine, now it will be locked. So it will not be built again. So it is reparsing everything because I updated the bitbake variables with variable 1 and 2 and 3, by the way. And now it should rebuild every BC recipe. Hopefully. Come on. Here it is. And now it is building. Wait, it is not building because it is still locked. Yeah, it is still locked, sorry. But why? This is demo presentation live. Okay, I can unlock it. bblock -r. Okay, bblock -r to remove everything. So I can just dump again the file. It is now empty, and if I rebuild, it will now rebuild or not if it is already in the S state. But I removed the note and warning. So here it is. Thank you for, yeah.
If you say -r removes everything, that's everything for the current architecture, right?
Sorry?
You said -r removes all the locks?
Yeah, all the locks.
But all the locks?
From all architecture, yeah.
All architecture.
Yeah.
Okay. Yep. Remember, we have a recording and we have live people.
So the question was, -r, does it remove everything or everything for this architecture?
Everything for everything.
So adding is just for the architecture, but removing is
for now, yeah.
For all architectures, okay.
You can submit a patch if you want.
I have one question, like regarding this looking, like sometimes in the recipe you have the option to do fetch, no stamp, and it will rerun forever. Whose will be the dominant here? Like if you specify in your recipe the do fetch or do compile with no stamp.
I did not try that. That's a good question.
Yeah.
I should definitely try.
Yeah. Okay. Thanks. Maybe because this is like for if you're using always the auto revision and you would like to make sure that you can rerun, it's good to know like which one will be dominant, like if they can interact with each other.
I guess if you're using no stamps, you don't want to use bblock. So that may be the reason why I did not test it.
Okay, thanks. Yeah.
Question here.
So is the main use case read-only root file systems? Or because I guess in your Python example, you would just use bitbake to generate the package, right? If you have a read-write root file system and then...
Yes, that can be yes, that's a use case, yes.
Okay. Are there other use cases?
Yeah, for example, I mean, Yocto developers often work on Python recipe or Rust recipe, you know, and when you're doing some changes to Rust, for example, Rust recipe, you don't want Rust native recipes to be rebuilt and all the package depending on that. So you just lock Rust native recipe and you can work. So you don't have even to use a target. You can just make sure that your changes make your image still build. So you do your development phase with Rust, and then you can switch over to Rust native, and you lock Rust, and you unlock Rust native. You know, so
it's built to build Rust and all the things which depend on Rust. Basically.
And avoid rebuilding Rust native and all package depending on it. Same thing with Python or.
Yeah, not just in this specific example, you could deploy just Python, right?
Yeah.
You don't need to lock it. And
yeah.
Okay.
Yeah, sure. But it was for the fun demonstration. Hopefully it was fun, but.
Yeah. Okay. Thanks.
Just 1 second, because on your question, we have an online contribution from Richard, and he says, "No stamp should win." I quote.
Thank you, Richard.
I have 2 questions. The first one is the warning you showed about the locked recipe. Is it shown every single time you run with bake, or only the first time?
No, it is shown every time, so it can be really verbose.
Yeah, because you can easily forget that you locked the recipe.
Yeah, so this is the reason why we wanted to have some warning messages and note messages to avoid forgetting about it. But it can be really verbose. So I need to find a way to be less verbose, but still have something to remind the user.
Yeah, and the second question is it difficult to backport to Kirkstone? Does it require some, let's say, a lot of backporting or not?
So it should work on Kirkstone, and it's just a Python script, so you can just copy it on Kirkstone.
Yeah, but you said you had to contribute upstream to scar the gap certain things like determining a signature for a single recipe.
Sorry?
For a single task, sorry.
I didn't get your question.
You said that you had to contribute upstream the possibility to get the signature for a single task.
Yeah.
And that was the basis of the question, that perhaps it would be difficult to backport, so because Kirkstone might be missing that.
No, I'm not. I don't think it will be too hard to backport. At least right now, with the option we have, you can run it on Kirkstone.
Okay, thank you.
Which one? Are they there?
The live stream, I don't get the link.
Ah, okay. I was so scary, he forgot the question. We technically have room for 1.5 more questions. Otherwise, this will be the actual planned coffee break now. No more questions? Oh, okay, he remember.
No, so if you want to backport it, I guess you can, but I think the stance of the project on this is to not add new features to LTSs and that kind of thing. So I wouldn't see this coming to Kaxon, except if you fork Pocky and you know what happened or what Ross said in the earlier talk, so up to you.
Make up your mind.
No, actually, you also figure out that the wiki.yoctoproject.org is quite outdated. We don't maintain it, so it's up to you to do it. But the best thing is actually to add this documentation to the official documentation, which is docs.yoctoproject.org. So if you find a way to, contribute this, it would be nice. Obviously, you can also update the wiki. That's nice. Then maybe we want to document the 6 state, like those very long variables, but I don't know what's the stand of the project of this on this, because there are some internal variables that we specifically do not want to document, because we don't want people to manually change them. So bblock would be an exception, obviously, because it's a wrapper around this. But yeah, so please send patches.
Yeah.
And thank you for bblock. It's quite interesting. Thank you.
Thank you.
Okay, that made up for 1.5 questions. I hereby declare coffee break for 20 minutes, and then we have got the next presentation, which I don't remember at the moment. Thank you.
Thank you.
I just need to make a stupid selfie because I'm herding cats here, and I don't know what the cats are supposed to do. I'm just herding them, and I need to prove that. Okay, we're on time. 11 o'clock.
Yeah.
And is it Tymoteusz and Daniil or?
Yes.
Close enough. Okay. Will talk to us about crazy things that are secure in some way, hopefully. Thanks. First time we've got a virtual speaker. I mean, imagine this. What a time to be alive.
Hi, I'm Tymek, and Daniil, as you can see, lives in my computer because he couldn't come in person. And we'll be co-speaking the talk about implementing trusted execution environment and secure storage within Yocto. So who are we? We're junior embedded systems developers at FreeMDev. Please keep that in mind, we're junior developers. We've been working together at FreeMDev for a year and 3 months, I think. We started at the same time, and also we study at the same faculty of automation and control engineering. And what is FreeMDev? So we're embedded and firmware consultancy group, and our main products are Dasharo, the core boot downstream, and Zarhus OS, which is an embedded Linux distribution aimed for security. So the talk is going to be divided into 2 parts. I'm going to give you the theory. I don't think I need to stand that close to the mic. I'm going to give you a brief theory, high-level overview, and then Daniil will introduce the, in practice, how that translates to Yocto. So I want to ask you some questions to better get your familiarity of the concepts that will be covered during this talk. So please raise your hand if you're familiar with the concept of trusted execution environment. Okay, that's a lot of people. That's good. Please raise your hand if you've heard or have experience with ARM Trust Zone. Again, that's good. What about root of trust? Great. And I guess you've all also implemented it within Yocto because we wouldn't be here otherwise. So yeah, I'm not gonna bore you with details. I guess everyone could raise a hand here because we all kind of need secure execution and data isolation. Okay, so because we're all experienced in the topics, I'm just not gonna introduce it like from the bottom up. I'll just cover general stuff, what I found when working on this, researching this stuff. So yeah, starting off, what is trusted execution environment? I really tried to find a good definition for this presentation, and it turns out that every vendor and consortium and group and whatever has their own definition. And some are more outdated than others. Like you may be familiar with trusted execution environment being only the secure area of the main processor. I think that's the one that's still present on the Wikipedia. So yeah, I'm gonna use a definition from the book Building Secure Firmware, which you can see on the screen now, which really only talks about confidentiality and integrity of code and data inside of the secure area. And that's the common part between all those definitions. Here you can see the how Confidential Computing Consortium defines trusted execution environment. They have micro conference, I think, as well today here at this building. So yeah, if you're familiar with the CIA triad, we have confidentiality. So the data is only accessible to those who are authorized to see it. And we have integrity. So we ensure that it hasn't been tampered with. But there's no availability here. So this definition of the doesn't specify that in case of denial of service attack, it should withstand it, only that it shouldn't leak the confidential data in case of a denial of service attack. So following through with this definition, like as I said earlier, older definitions only defined TE as secure area of the main processor, and it can still be encountered in this way. Like ARM Trust Zone is exactly that. Also, Intel SGX and AMD SAV. I hope I'm not butchering those pronunciations. Nowadays, it can also be a coprocessor within the same system on a chip, like an integrated TPM module, or Apple Secure Enclave also does the same architecture. Yeah, but those two architectures are actually there are vulnerabilities in it. So you share resources. So they're vulnerable to side channel attacks, especially because clocks are shared memory buses and power. So an attacker could deduce some information what's going on in TE based on that. The problem with the previous one, and that's encountered within ARM Trust Zone, I have to really bend over in an awkward way. So I'm not really seeing notes that good. That's better. This solution also makes it that TE fights for resources with the rich execution environment. And the best solution and most costly is the coprocessor based TE that's external, so like a discrete TPM or Google Titan. We're going to focus on ARM Trust Zone, especially for Cortex-A, because that's what we've worked with mostly. So it operates on exception levels, as you probably know, which roughly correlate to x86 protection rings. So this is a high-level overview. Some may say that secure partition manager shouldn't be in exception level 2. That's correct, but there are implementations of it there. And in my opinion, it's better to visualize it that way. It's easier to understand because secure partition manager acts as this sort of hypervisor for trusted applications. Okay, so maybe what's going on here? So you have your secure world, which hosts your trusted applications, like, I don't know, your banking details, your banking private keys are handled by this secure world. So you use your app banking application in your retries, which might be Android, Linux, whatever, and it makes a call to the secure world via the secure monitor, and secure monitor acts as this decision maker, not the good word, but it restricts the access to memory regions of the rich execution environment. And that's mostly what ARM Trust Zone does. It's keep that in mind. I'm gonna go back to it in the next slice. Yeah, so not every vendor enables trust zone. Then we have problem. Raspberry Pi, one of the most popular Tinker boards, doesn't support it in any way. So the only thing we can do then is try using a software isolation instead of hardware isolation. So a good solution would be a static partitioning hypervisor, which can also restrict the memory access for VMs. Because they're at the start of virtual machine, it's assigned statically, and during the runtime it doesn't change, so it can't access a memory that hasn't been allocated to it. Okay, so root of trust is a very broad topic. I really like this definition of it. And it could be entirely a presentation on its own. This kind of jokey definition gets the point across, but what I'm trying to say is ARM trust zone in itself doesn't verify the trusted OS. It needs an underlying hardware like SecureBot, which is provided by ARM trusted firmware A for ARM Cortex-A. So a malicious trusted OS can be initialized, and secrets of your banking trusted applications can be leaked out. I think Daniil will cover this a little more in the practice part. Yeah, so wrapping things up slowly. The next aspect is secure storage. So when we have ARM trust zone doesn't actually add secure storage in any way. It needs to be provided by hardware. There are two ways of storing data in trusted OS. You could store them actually in rich execution environment, your Linux, Android, or whatever, and encrypt them with secrets that are available only to the trusted OS. But the problem is, as I said, trust zone only manages memory, really. So they still need to be loaded to the trusted OS. So secure storage is in the end needed. And most common ways to ensure secure storage are RPMBs, replay protected memory blocks, which counter the replay attack. And about what TE implementation you can run in your trusted OS. As you can see, only Yocto is really, Opti is supported in Yocto because every vendor provides their own trusted OS, really. And they're proprietary, non-open source, global platform compliant. If you don't know what that is, it's an standard API for both trusted applications and user space applications to communicate with those trusted applications. This Daniil hides the source of this table. It's actually modified Wikipedia. I just wanted to see what's on there, and I've looked for every one of those implementations, and so if their code is open source, that's why the T6 has a question mark on it, because it used to be, but now it points to a weird website with advertisements and casino stuff. So it's you make your own decision if it's open source then. So yeah, that was the end of my part. So Daniil will now take over and tell you how to integrate, how that translates into Yocto and practice. And I
Hello
need to...
there. Timek, have you...
Yeah, we hear you.
Switched?
I just...
have you switched to my translation?
Yes.
To my presentation? So, I'm now going to show how to apply some of the knowledge Timek presented you to integrate and use some of the functionalities of AT implementation on ARM platforms. I will show you that integration might not be as trivial as you think at the first glance. So, here's our secure hamburger, and we have a bunch of stuff to integrate. Starting from the bottom to the top, we have hardware with trust zone support, of course. No need to integrate this. And then we have firmware, call it ARM trust zone firmware, which supplies us with secure monitor, which is responsible for communication between the worlds. On the secure side, we have open portable trusted execution environment operating system, as Timek has already said, which supplies us with core secure functionalities such as secure random number generator or secure storage. Then we have trusted applications, which holds specific secure functionalities such as cryptography, key management, and etc., etc. On the normal world, we have our favorite Linux with its drivers, which are responsible for communication with hardware and, most importantly, with secure side, and user space with cleans, libs, and tools, which take full advantage of our secure functionalities of our secure world. So, to the implementation then, we have actually two paths. This is the first one. We could compile the trusted firmware and OPT from the source, and here MetaARM has a great support for this. You can find all recipes needed for those two elements, which is trusted firmware and OPT, and even additional recipes for development, such as test suites for AUTOREV and OPT, and trusted application development kit for OPT. And most importantly, and it has another recipe called OPT client, which provides us with this applicant, which will be discussed later. So the second path, if you are unlucky and your vendor have not published the code for OPT and trusted firmware, and you have to use their binaries precompiled and actually which is not secure, and to use their development workflows, which are probably outdated, lack support, and just inconvenient. And if you are unlucky, the integration becomes a pure nightmare, especially in Yocto. So, but let's assume you have access to those images from vendor, or you have compiled it by yourself, and now you want to integrate it in your system. And first thing to do is to boot them, and this is bootloader responsibility. In this case, it is to boot. It loads and verifies the images. All you need to do is to say to boot that you are using TE and link those images during compilation time in a recipe. Worth mentioning that if you are using vendor binaries, there might be some problems with format, because some vendors use raw binaries, which are not accepted by Pinman boot tool, and you may have to do some workarounds here. So after U-boot has loaded all images from secure side, trusted firmware, and OPT OS, it starts to load our Linux, and at this time Linux should know about presence of the T components, so, and about memory it uses. So you need to inform Linux about it by adding reserved memory inside Linux device tree before compilation. You should enable AT Linux driver as well, because T driver is a key communication component between Linux, between normal world and secure world, and to add a node into device tree as well for the driver. So after you have all needed configurations, you could add them to the appropriate BB appends in your layer according to examples in MetaArm, and then group these packages into and add to your image, for example, via package group. Here you can see trusted firmware, OPT, OS, and test, which needs porting. OPT client actually don't need porting, and lib11 is an example of user space application, which will be used in our use case in the next slides. So here is our use case. It's actually secure storage and its implementation in OPT. We have here our two worlds, secure and normal world, which communicate with each other via secure monitor and its calls. As I said, OPT driver is a crucial communication node here, and there is actually three communication paths available. The dark one is a common one, which is used in all use cases of OPT OS, and it is responsible for communication between clients and TAs, and between OPT OS and TS applicant. About TS applicant. TS applicant is a very important user space application for OPT, because it is responsible for all actions, OPT actions in user space, because OPT OS by itself cannot modify, for example, file system or communicate with hardware. It needs support from the normal world. So there are two types of secure storage implementation in OPT. The first type uses Linux file system for storing encrypted data, and the second type uses EMM-CRPM by secure partition for storing encrypted data. These two types are outlined on the diagram by colors. You can see them. And are configured during OPT OS compilation. The secure data, our secrets, are managed, created, and manipulated only inside OPT OS and TAs, and leave secure world as an encrypted data, only to be stored on our secure storage. So, and we have done some experiments in integration those implementations, and we took both paths, but the vendor binaries were first, because we were integrating secure storage on Rockchip RK3566 based platform, and the vendor do not provide code for trusted firmware and OPT, and we had to use their binaries. Although we were able to integrate the binaries and boot them not without a huge list of workarounds, of course, we met a really big and difficult problem during verification of needed functionalities. As you can see, the problem is connected with LDLF, which is a part of OS and is responsible for loading trusted applications. So we actually cannot even communicate with the trusted application because it is not loaded. And the binaries also did not pass most of the test cases of OPT test suite, which is pretty bad. And yeah, the problem is really hard to debug. After spending some days scratching our head, we have decided to do a port by ourselves, and actually it's lasted a bit, but we get a lot of knowledge and a more stable behavior of OS here. So we were able to port, integrate, and boot the OS, and even verify our use case. Here you can see we are using PKCS 11 Linux user space tools to communicate with PKCS 11 trusted application located in OS, and we are able to communicate, initialize, and use trusted applications tokens for storing keys. Our OPT port has also passed all of test cases, which is pretty nice, but there is one huge problem here with our port. The problem is that the vendor do not provide us registers, map, or any documentation about MMU, Memory Management Unit, which is actually a crucial part of implementation. And therefore, our OPT and secure world is not separated completely from rich execution environment. So the solution, the port is not secure, unfortunately. And actually, this is the end. I wanted to outline that all of our experiments can be found in our repo in our project, Zarhos OS, which is located on GitHub. We also planning to migrate and share with the community all knowledge, a lot of knowledge we have about, for example, secure boot, TPM, over there, updates, and many other. So feel free to visit and contribute. Here are the sources we used. I prefer documentation, Tymoteusz prefer books, and questions and answers, finally. Do you have any?
To either of us? Or in general?
I'm actually surprised you managed to even load the Rockchip binary for Opti, because this is absolutely not supported in U-boot upstream. So is there something you can actually share so we can somehow go in the same state as you were?
Daniil, do you hear the questions that are?
Yes, I have heard the question. The topic is pretty complicated, and though I wanted to share it in presentation, I just don't have time. So you could visit Zarhos OS project and Meta Zarhos layer especially, and there are pull requests with all patches and needed information you need to do that.
To be honest, it's kind of embarrassing, but we got the binaries like not so long ago, and it's we didn't like make it to the conference as we thought it would, but it will be soon available publicly. Yeah.
Don't get you, but okay.
I do have, if something's one topic that I would like to maybe brainstorm a little, if we're talking security. SecureBot at Yocto, especially Meta Secure Core, I felt an issue, I think in March, that private keys are used as files in the user space just saved as text files. And maybe it shouldn't be that way. Like, it's a security vulnerability. So maybe we could brainstorm it later, because I haven't found a solution within Yocto yet. So please enlighten me if it's possible to use some HSM or HST. Thank you.
More questions? If not, then I actually have a crazy question to Daniil. How does it feel to be the first ever live virtual speaker at a Yocto event?
Actually, pretty okay. I'm nervous because it's my first conference actually, but actually pretty convenient. Just compare remote and remote work to work in office. It's the same feeling, I guess.
So you don't
coffee here and some snack and. Yeah.
But you're missing out on the real experience, like not getting coffee lines and non-functioning machines and floods in Vienna and everything.
Everything has its pros and cons, but just I'm just definitely been some conferences, but not today, unfortunately.
I'm just being stupid because we have time, and I wanted to point that out. We've actually never done this, and first thanks to you guys for preparing this. But actually, people usually don't realize this, that a lot of let's say kicking and hoping and red taping, and actually I have got pink gaffer tape on me, goes into making this all technically work. And we this morning I've had some like shocker moments, and I particularly want to thank the audio and video guys here, because they've done an excellent job in basically like fixing every problem that we've come up in 15 minutes. I've never seen this in an event venue before. So great job.
Also, big thanks from us for allowing Daniil to be here with us.
And Tymoteusz too.
If there are no more questions, then you have 10 minutes to take a piss and come back for more Yocto.
Thank you, everyone.
See ya, Daniil.
See you too.
Offensive. Müsste jetzt das letzte sein, was wir noch haben, oder? Ich kenne mich selber nicht mehr aus. Voll schrecklich. Pre-Talks. Oder? Ja. Yeah, and still have 1 minute. 1 minute. I have an internal disagreement here because my watch says, no, okay, now it says 45. Welcome. Is it Chirag? Chirag?
Chirag.
Chirag. All the way to us because I've been informed you've been one of our new faces here, so we're always glad for infusions of fresh blood and thoughts. Mm-hmm. The stage is all yours. Bring fresh knowledge to us all graying people and tell us what we should do better in the future.
Yeah, sure. I will try. Yeah. So, hello everyone. So, today I would like to talk about how we can leverage Docker containers to streamline our Yocto build process for embedded system. So, I'm from TI, and at TI we believe in upstream first mentality. So, if you see, we have a bunch of open source projects we are contributing to, and I hope in upcoming years you will see much more logos here. So that's my wish. Let's see. A quick introduction about myself. I'm a software engineer in TI. I joined as a college graduate, and I have been working for the past 2 years. So my primary focus lies in building custom embedded Linux distribution for TI's ARM-based microprocessor using Yocto project. A quick overview of what is the agenda. I will start with the introduction of Yocto project and Docker. Then I would go through the drawbacks of running Yocto builds on host. Then we will move on to see how Docker addresses these challenges. Then we'll go more detail about how Docker images can be used for Yocto builds. So starting from steps to build a Docker image from the Docker file, how container registry can help, and how to start a Docker container. Then I will do a quick live demo of building a Beagle Play image via Yocto using a Docker image that TI provides on its GitHub container registry. After seeing how Docker helps, we will go through few cases where Yocto builds might still fail inside a Docker container. And yeah, we will conclude. So disclaimers, this is a technology presentation and not a roadmap or commitment from TI. So the opinions here are presented by me and may not reflect to that of TI. A quick introduction about Yocto project. So as we know that it's a build system that helps us in creating packages from the source code. It's based on Bitbake and open embedded meta layer. It allows us to create a custom embedded Linux distribution regardless of the hardware architecture. Now, what is Docker? Docker is another open source containerization platform which allows us to package application and their dependencies into a lightweight and portable containers. So what you eventually do is you have a Docker image, put all the dependencies you want with respect to your Yocto build, and build a Docker image and store it onto a container registry. So we will see how we write this Docker file, convert that into a Docker image, and basically how we create containers where we actually run our Yocto builds. So what are the drawbacks of running Yocto builds on host? So Traditionally, we have been running Yocto builds directly on our host, where we just go to the Yocto documentation, download the bunch of dependencies which are related to the packages, which are related to our distribution, and then start the Yocto build. However, this approach has some drawbacks. Firstly, the dependency hell. So managing dependencies and ensuring that the consistency is across all different development platforms can be a challenging. So it might happen that you are working on a Ubuntu 2204 distribution with your set of dependencies, and your colleague is working on a different distribution like Fedora with other set of dependencies. So second is the reproducibility issues. So documenting build step doesn't guarantee consistent results across different machines. So we have the Yocto Foundation who is documenting for many distribution out there, but still that doesn't guarantee that we might end up having a 100% error-free Yocto build. And lastly, host system variability. So as I mentioned earlier, it might happen that each individual is working on a different Linux distribution, so which has a different set of libraries, and it might affect the build process. And all this is resulting into this bad red error that we generally hate during our Yocto builds. So yeah, how we can use Docker to address these challenges. So Docker container provides an isolated environment for Yocto builds. So what it does, it provides consistency. So what we can do is just build the Docker image, put it onto a container registry, and ensure that everyone pulls the container image and uses the same. So it ensures that even if you and your colleague are on different distribution, you are still building the Yocto build with the same Docker image and which has the same environment. Second is portability. So developers can share their Docker image either via Docker registry, or Docker also provides an option to convert your Docker image into a tarball, which you can share it over an email as well. So, and lastly, avoiding host system interface. So Docker kind of shields the build process from the host system changes. So yeah, that's how Docker helps in addressing the challenges we see while running Yocto builds directly on host. So moving on to the steps to build a Docker image for Yocto builds. So prerequisite would be to install and set up Docker on your host machine. Then step one is to write a Docker file. So let me go through and explain what a Docker file looks like. So Docker file is basically a text document where you have a bunch of commands, and you say that these are the set of packages which I need in my Docker image. So starting from the from statement. So this statement ensures that the Docker image which I am planning to build should be of the Ubuntu 2204 distribution. So the final Docker image, the base distribution of that would be Ubuntu 22. So this is fixed. Now, what we need is the set of dependencies. So if you go through the Yocto documentation for Ubuntu 2204, we have this set of dependencies which are needed for Yocto builds to get started with Yocto builds. So what we do is we use run command, and we install the set of dependencies in the Docker image. Oops, yep. And the other run setup is to just set the local permissions and to reconfigure bash as the default set, because we know that in Ubuntu it's dash which is prepared, but for Yocto builds we need to switch to bash. So yeah, we have this depconf set selections which we use and reconfigure the dash to not reconfigure basically the default shell to not be dash. Adding a bunch of users. So here I am basically creating a new user because I can't run Yocto build as a root user. So I'm creating a user which I'm naming it as TISDK, and then I'm adding it to sudo words and making it passwordless just because I don't want to have a password. And And yeah, these are some bunch of locale settings we need. And I'm setting the user to TSDK as well. So this is how my Docker file will look like. So to convert this Docker file into a Docker image, all you need to do is run a Docker build command with inside the directory where you have this Docker file. Ensure that you give a good name to the Docker image so that once your images get built, you can identify it quickly. So we now have the Docker image on the host, but still, those were like two. There was still two steps that we were doing: writing a Docker file and then converting to an image. If you want to avoid the steps which are done in previous slide, all you do is build the Docker image once, push it to a container registry so that you don't rebuild the operations, redo the operations which were done previously. So yeah, we have a Docker image hosted on GitHub container registry, which can be used for Yocto build. So all you need to do is just Docker pull this image, create a container, and get started. So now I will show how to create a container. So we now have the Docker image ready on our host, either by building it ourselves or pulling it from a container registry. So the final step would be to start a container and get started with the Yocto builds. So what I will do is, to start a container, what we do is we run a Docker run command. And with that, one important thing is for Yocto builds, as we know, we need few GBs of space, a hard disk space. So for that, what you should do is firstly and create a variable and basically assign a path where you want your Yocto build to get started. So I will just use that, set it to a work directory, and I will just mount the path which is on my host to home/tsdk, which is in my container. And just Docker run command with the Docker image is what I need to do to start a container. And as soon as I run that, I am inside a container. So quick summary on the Docker process. So either we build a Docker image from the Docker file or pull it from a container registry. Then what we do is start a container, and now we can go ahead with your Yocto build. So the only two steps which we have added is this before the Yocto builds. Yeah, so now I will try to show you a live demo where I will be building core image minimal for Beagle Play using the Docker image from the container registry which I showed. So if you are, so for beginners who might not be aware of what is Beagle Play, what they can do is to see which layer from Open Embedded Core is supporting that. What you can do is just hop on to the layers.openembedded.org and switch to machines. And here you just search for Beagle Play. And if you search, you see the machine name and you see the BSP layer which supports it. So it's the Meta TI. So that I will be using for my demo purpose as well. So firstly, the first step is to get a Docker image. So firstly, I will see if I do have some Docker image. No. So what I will do is I will run the Docker pull command and I will fetch the Docker image. So what this does is, what Docker will do is fetch the image from the container registry. So I had the layers already in my system. So what it did is just clubbed the individual layer, created the Docker image, and now if I do Docker images, I have the layers. So pulling of Docker image is done. Now the next step is to start a container, but before that, as I said, we should ensure that we have a dedicated work environment. So for that, what I will do is I will export the present working directory as my working directory, which I will be eventually using for my Yocto build. And then I will just get started with my container. So these are some options that Docker provide the Docker run command eventually provides. First is the interactive option, which basically allows me to provide a standard input when my container is started. T is for TTY, so it provides me a sudo TTY where I can basically work on. And -v is to mount volumes. So as I mentioned, I will be using present working directory, so I mount it to home/tisdk. Bash RC I am mounting is not compulsory, but right now as I am working on a TI-based VPN setup, so I need some bunch of proxy setups for my Yocto build, which is in my Bash RC. So I am ensuring that that is also present inside my container. So that's it. And -w is to just specify the starting working directory. So as soon as I hit enter, I am inside the container, and if I do present working directory, it will be home/tisdk. So yeah, now I am inside container, and the next step is to start with Yocto builds. So for that, as we saw that the meta TI layer provides BeaglePlay support. So what I will do is use the OE layer setup script. So this is basically a setup script that TI still uses, which was based on Armstrong distribution. So it's highly inspired from that. So what this tool does is eventually it has a script, OE layer setup scripts, which will help us in layer configuration. So what I will do is just use a configuration file and run that script, and I will ensure that we clone all the layers. So by the way, till the Yocto layers are cloned, I would like to show the container registry page which we have. So we have documented all the process which I have been running through right now. So feel free to check it out. It's now cloning meta TI, which has the machine configuration for BeaglePlay, and so my next step is to, which is the last step, is to bitbake a core image minimal from OE core using the BeaglePlay machine configuration. So okay, so meanwhile the cloning happens, let me probably done. So
will you say how you copy the files back to the host?
yeah, we can do that. Yeah. So we are.
Is this publicly relevant information that you might want to share with our remote listeners? Slava says yes.
So
it's just Michael was asking whether Chirag is going to share how he copies files back to the host directory. So my suggestion was you could just bind mount the build directories right away, so they end up in the host and not in a container.
Yeah. So as you mentioned, so I'm mounting my host system inside the container. So for storage, I'm still using my host system. So the files are eventually present on my host. So yeah, my cloning is eventually done, and I will move on to my build directory. Just few environment settings which we do, and I will bitbake a beagle play image. So yeah, eventually my build is started, and yeah, this is how you run your Yocto build inside the Docker container. So the entire build is running inside a container, and yeah, so meanwhile the build is in progress. I will jump onto my slide to show what are the things which Docker doesn't guarantee. So yeah, is there any possibility that the Yocto builds will still fail inside Docker? So yeah, the answer is obviously yes, but most likely I have jotted down few reasons, and it can be one of the following. So either your host kernel is too old. So even though Docker provides a virtual environment, it uses the same kernel as that of your host system. So it might happen that your kernel is too older and Yocto is not supporting that. So ensure that you are still using a latest kernel image. Secondly, it might even happen that host has some packages which may conflict bitbake. So I would like to show a thread which was happening in bitbake. So it was related to AppArmor, which is a Linux security package, and it was made mandatory in Ubuntu 24.04. So what it was doing is basically it was restricting the non-root users to basically access the storage, and it was creating some permission issues. So even if you have a Ubuntu 24.04, but on top of that, if you have a Docker container which is still Ubuntu 22, still you might face this error. So it might happen that there are some packages in your system which are conflicting the build. Third reason is definitely not having enough disk space and RAM size. And lastly, there might be some issues in your own custom implemented meta layers, and other issues can still exist, like network issue, repository servers going down, etc. So a major takeaway from this session would be prefer running your Yocto builds in a containerized environment. These are a few references which I have attached, and yeah, I still have my Yocto build running without any errors. So yeah, it works perfectly fine inside a Docker image as well. And yeah, credits and acknowledgements. So I would like to thank Texas Instruments, the Yocto project, and Linux Foundation for giving me this opportunity. And you can contact me on my email ID or on LinkedIn as well. And yeah, I am open to questions.
I just want to say that I'm using Docker every day on my computer because I'm using a non-supported distribution. So this is working as you described. And I even go further. I added some big, ugly aliases. So I can just run bitbake and my command to run it like it was normal, running normally on my computer. And during my demonstration earlier, I was running Docker. And I'm pretty much sure nobody noticed it. So it's working, and it's working really great.
Okay.
Thank you.
I think there was one comment here. Is it direct? Is it on this running thing or on? No, we're not out of time. But Juliette triggered me on something, which you probably actually know. You might have noticed that we've mentioned Josh Watt a couple of times already, and there's this thing that he created. It's called Pyrex, and it's awfully similar on a lot of steroids. So it's basically, it sets up a reproducible environment for Yocto developers using very, very similar techniques. And as you said, you created aliases and all of this stuff. Maybe look at what he did. Maybe there can be some cross-pollination or growth together or whatever. But you're definitely not the only ones who are doing this. Yeah. The sad thing is that we seem to have like 10 separate incomplete implementations of this instead of one that actually is useful for everybody. Then Slava, and then I think we have...
The question was, you mentioned some incompatibilities with Ubuntu 24. Is it on the host or in the container?
Yeah, it is on the host. So even if you have a Ubuntu 24.04 host, and by default, AppArmor, which is a security package, which it was enabled by default. So even if you, let's say, have your Docker image on 22.04, you will still face an error. So that was my observations. So because this happens because Docker is still a process on top of your host system. So eventually AppArmor would be able to detect that some non-root user is trying to access something. So yeah, eventually it throws that error.
Another one is here?
Yes, I also use Docker a lot and recommend also to mount your export your display information and if you have a network to be able to run a QEMU and task EXP and similarly inside your Docker container.
Can you be a bit louder? I was...
Sorry? I just said I also use Docker a lot, but usually I also export my display and SD bus inside together with my network card and 2N, because then I can able to run task EXP and QEMU inside the Docker after I built it.
Okay, so you are unable to?
He is able to.
Okay. Okay. Apparently the...
I tell you, 15 incomplete incarnations. Can you all just get into one room?
I was
wondering... if you want, we can collaborate and come up with a single solution.
Thank you very much for the presentation. It was very interesting. And I'm pretty sure everyone in the room, one way or another, uses containers for reproducible builds. I personally tend to use CAS, and Joseph mentioned about this ongoing effort to have something within the Yocto project. So why do you start from scratch with creating your own Docker image and Docker file instead of using CAS or any of the other solutions?
Yeah, good
what
question.
What is the benefit?
So if I heard right, the question was why did we start with a new container image from scratch rather than using corpse or maybe CAS container or stuff like that, right? Yeah, exactly. So yeah, the use case which TI had was not to just support Yocto builds with a Docker container. So generally what we do is, so if you might be familiar, we have the task which we create to generate the SDK as well from Yocto. So generally what TI does is when we have a final tag on a kernel and U-boot, what we do is generate a SDK out of it. And the requirement was that SDK also should be able to be run inside the Docker container. And now that SDK has some bunch of tools and utilities which has additional dependencies other than Yocto build. So yeah, so that was the reason to start from scratch and create a Docker image which will solve both the purposes. That is the Yocto build as well as the tools and utilities which we have. So our U-boot also for K3 device supports uses the binman tool. So there are bunch of dependencies which are related to binman which are not needed while Yocto build, but will be needed if you want to use the SDK and basically compile U-boot from sources. So those were the additional, basically the set of dependencies that we wanted. So the goal was to have a single Docker image which would support both the SDK as well as the Yocto builds. So that's why we started from scratch.
Other questions or early lunch? Show of hands for other questions.
I still have my build running, so it doesn't fail.
We all know the feeling. Show of hands for early lunch. That's more than for the questions, which by popular vote and democracy in open source, we hereby declare early lunch.
Thank you.
Thank you.
I do have 2 lunch suggestions from the LF staff, so if you aren't sure where to go, come find me and we can, I can't pronounce either of the names, I'll just be clear. So I'll show them to you on my phone if you need a lunch suggestion. All right, thanks.
And I think we're back in 1.5
Oh, hello, does it work?
Stuff should be working.
So it works, okay.
Yeah, okay, we probably have like lost 5 people or so.
Still at lunch, that's what I heard.
Obviously, but I think the crowd is almost complete. So, welcome back after lunch. Please don't doze off during the next lovely presentation by our wonderful Slava on how to not use AUTOREV.
That was a spoiler. I try to not to come to any harsh conclusions.
Any more questions?
Here, you know? So, everybody knows what AUTOREV is, right? Who is using that? Who is using that willingly? Let's try to find out why you do that. So I quickly introduce myself. My name is Vyacheslav Yurkov, but I present myself always like Slava because it's easier for everybody to remember. I worked in different companies during my career, but I'm now a full-time contractor and freelancer. Haven't come up with a company name yet. So feel free to reach me or using those contact details below. I started my Linux career or passion more than 20 years ago, and I try to regularly contribute to a bunch of open source projects, especially Linux kernel, Yocto project, and it mentions that I maintain OverlayFS classes and Open Embedded Core, but I recently took over the maintainership of OverlayFS tools as well. So there's some helpful tools which you could use with overlay. They are in Meta Open Embedded layer. Yeah, that's short about me. So AUTOREV, let's try to see what it is, how to use it, how it works, and maybe just discuss, should we use it, should we not use it, and where are the trade-offs, because sometimes it's really looks like a useful and nice tool to have. The last one is like a bonus, just showing how to handle multiple URLs in the one recipe. So AUTOREV. I took my examples just from looking at OE core recipes. And that's just EU dev recipe I found in OE core, but it does not use AUTOREV. So you see the source URI, it sets the fixed address and uses HTTPS. I just highlighted it. So it takes the whole archive bundle, and it's completely clear what's going to be downloaded. It also mentions a couple of files which are local to the BSP. So they are just fetched as files, basically. This is an example of a recipe that does not use AUTOREV. Yeah. Exactly. That's the point. But let's come to that later. This one can use arbitrary revision because it uses Git version control system. This is also example of a recipe I took from the OE core. That's a DTC compiler, device tree compiler. It uses a main branch and it uses a Git fetcher. And now you see another variable, source revision, and it's set to a fixed value. Oh, that is a typo. I forgot a quote. And you always fetch this revision. So there is nothing arbitrary about that. It's always going to be fetched from the main branch, from this URL, using HTTPS protocol with this fixed revision. What happens when we use a keyword AUTOREV? So that's an example with OverlayFS tools I mentioned. I still use the Git URL. But now, instead of setting a fixed revision, I set a keyword AUTOREV. And it looks like a variable, but it's just used later on to substitute the actual revision. One important note here is that not only setting the AUTOREV, I also set the PV to that specific value. This is, okay, first of all, what it does, it fetches the latest commit from the master branch. And the latest at the moment when you try to build it. Now going back to the PV. This special value is needed because when you do a lot of subsequent builds, you want to distinguish those packages. And for that, you need a PR server running. So that variable is later used in the PR server. If you want to know what it is and how it works, you should watch Michael's talk from the 2 days before.
Just for the record, the source PV variable is not needed anymore since Kafka.
Since Kafka, okay, that's something new, thanks. So it's always default to AUTOREV or default to what?
You should still have the something plus git.
Something plus git, okay. In the PV you mean?
Yeah.
Okay.
But this also tells if it is bigger than 1, 0. How else will you do that? I mean, if I have a stable version 1, 0,
yeah.
I have an unstable AUTOREV.
This is just example values. Yeah, so I didn't mean it to be like complete working example. It's just example value how to work with AUTOREV. Yeah. Yeah.
Let me give you a microphone so everybody else can enjoy your wisdom, or at least your verbal output.
Yes. Yeah. So the question is, if you don't use, I mean, the PV line also says what I'm building now is bigger than 1, 0.
I need a different strategy for my talk later.
You still need the PV line. You just don't. You should not have the source PV variable. So it should still say something plus git, and then Bitbake will automatically, magically convert the plus git to the plus git and part of the SHA revision.
Yeah, I left at the bottom the links to the official documentation where that auto-incrementing and the percussion version number is described just for the future reference. So most of the slides have it where I took it from. All right. So why it can come in handy? Of course, when you want to fetch the latest revision from the specified branch. What if we need both of them? So this slide might appear out of order, thanks to Ross, because I just wanted to demonstrate what if you want to have a fixed build. So again, this on top is the same excerpt from EU dev recipe source URI. But you also want to have or have an ability to fetch the latest one. For that, you could use the BB class dev upstream. In order to use that, you have to use BB extend with dev upstream :target, and then set for this specific class, set the URL of the version control. If I'm not mistaken, probably only Git is supported right now. But I need to look it up. Yeah, that's right, good. And then you also set the source revision. It does not have to be AUTOREV. That can be set to any other fixed revision that is going to be used with that source URI. And then you also set the PV. It's similar to the previous slide, but this PV is going to be used in your local conf or whatever other configuration snippet where you set the preferred version. Then this particular set of source URI, source revision will be used. Again, that might appear out of order because I come back to the similar approach later. So what about the fetchers? So those are features we currently have in a bitbag documentation. There might be a bit more because, for example, for Git, we have Git submodules, and there's also such implementation as Git and Next. So I didn't specify them all here. Some of them I even don't know what to do, like S3, for example. Not all of them, of course, support AUTOREV. Like Robert mentioned, there are file fetchers. So AUTOREV doesn't do anything. So the AUTOREV is supported in those. So basically, only in those that support source revision. So in the fetcher implementation, there's a function which checks if the source revision is supported in the fetcher, then you can use AUTOREV. For CVS, I have a bonus slide here. So technically, AUTOREV is not supported. But you can use, for the CVS fetcher, special value called now for the date argument. It technically forces the fetcher to just check the version control every time. But it's not AUTOREV, because CVS is a bit older version control system, and there's no such notion as a revision. It's file-based. All right, so how does it work behind the scenes? When you call the bitbag and some recipe. So then the bitbag starts the server, and the server has a component called cooker, which in turn calls the parser. So that's a parsing stage, basically. All the recipes are being parsed in order to know the revision and the version of each recipe. So the parser checks the fetcher modules which are used in each recipe and combines that to basically to construct the PV, the version basically which is used. But so far there is no access because this is just a simplified version without AUTOREV. So parser always accesses the fetcher modules, but not always accesses the network. And then when this information is available, the parser passes it over further to the cooker, and then it spawns other build tasks. So it's just worth noting that the network access is usually restricted to the fetch and might be also on pack task. I'm not sure. That was a Richard note here. So what happens in the AUTOREV case? It's almost the same, but the fetcher module also has to access the network in order to construct the revision, which is going to be fetched later, in the later stage, and in the actual do fetch task. I mentioned there HTTP FTP fetcher, but obviously that also doesn't work with AUTOREV, so just to see what happens. The link here to the good description of how bitbag works internally with all those components for the cooker, parser, and fetcher, and also a good article on that in the Architecture Open Source Application book, the volume 2. So, do we need it or not? So why would you use AUTOREV? Why would you not use it? So in the case the AUTOREV is not used, the big plus is you get a reproducible build because you always know what you're building. And on top of that, when you, of course, develop and you do that in the same workspace, then this information is also cached, and the subsequent build are going to be faster. But the downside, when you have a fast development environment, when you develop something and you need a lot of changes, you need to find a nice way how to update the recipe information, because otherwise you're always behind. So when AUTOREV is used, no reproducible builds anymore. So when you build something once, in a few hours, you can end up with some more information in your master branch, if you use a Git, for example. But it's really convenient when you have 50, 100, 200 repositories, and the development is really fast, and a lot of teams work on that at the same time. So from the CI perspective, that is really convenient, because you always try to build the latest and to make sure that it's still compiled and ideally also all the test pass. And as a downside, because it's AUTOREV, the recipe is parsed every time. And then the fetchers also access the network every time to know what to build. So what can we do? So can we combine that to use that to get a stable build and to also somehow achieve the fast development environment where all the CI teams are happy? Let's see what we can do. So that was just my metric. So my observation, I had a project where you have a big team, like more than 50 people, then it's really convenient to use AUTOREV, like I said, and especially when you have pull request, merge request. I'm not starting any fight with the pull request, but a lot of development processes use it. And the team size is big, much bigger than 20 people. Then, of course, this is really convenient to use AUTOREV, especially in the integration pipeline, to make sure that the latest development still works, still compiles. That's just my personal observation. So what can we do? We have a build history plugin. It can be enabled by inheriting the build history class and setting build history commit to 1. There's a link with more documentation, what actually happens when you enable that and the build artifacts you get following that link. But at least what you get, in the build directory, you would get the directory called build history with the information about all the packages built. So here I built my overlay-fs tools package setting the AUTOREV, and it generated the file called laser source revision. So basically, it just stored my source revision, which is it found during the parsing, and it used during the build. So the build history also provides, it's not a build history. I think it's another binary, but I don't remember correctly. If you source the environment, it is available. It's called build history collect source revision, and that does exactly that. It collects all the source revision information from the build tree. Not only with AUTOREV, it can collect everything, so there are more parameters. Again, you can find them following that link. So what you can do, you can save this file, not only the one I just showed you from the overlay-fs tools, but from all the AUTOREV software you use. Save it to, for example, to sourcerevision.conf and put that into your local conf. That way, you at least have the way to reproduce your build after that. The second point here is what you can do. It's a bit orthogonal to the build history, but you can set the source revision policy to cache. That works if you build your image at least once. Then revisions are cached, and you can rebuild it again, but that might have some side effects. So it will not access the network, for sure. It will use all the revisions which are already cached. But if you change something, and you still expect something from other teams in other repositories, you need not to forget to put it back or comment it out in the local conf. Otherwise, you again might see some unexpected results. You expect one thing, but the fetcher just didn't check what has actually changed upstream. The cache policy is also useful to check if you can rebuild everything offline, so without the network access. But again, it's a bit tricky to use, because you put it there, you forget it's there, and you need some more changes. Even though you fetched new changes from your layers, it will still not go to the network because you have BB source ref policy set to cache. So what if we don't use AUTOREV? We need to find a way to upgrade the recipes. So how you do that? So there's, of course, the manual upgrade. You just check the recipe manually, upgrade it. Works well, sometimes slow, but depends again on the project. If you just need to bump up the version, that's pretty trivial. You can do that with the dev tool. I did not include that link, but in the dev tool manual, there's a list of commands how to follow that. Probably I have it. I should have had the slide how to do that. There might be another way. I saw some customers did that. They had a custom scripts that just bump up the versions of required components. And I know that Open Embedded Core and I think Meta Open Embedded too, they use Auto Upgrade Helper. I actually haven't seen any clients using that for their own layers. Maybe if you know, tell me. I haven't tried to bring it up myself, the Auto Upgrade Helper. So the way how to upgrade it with your custom scripts, of course, that depends on the version scheme of the project. Some project use a conventional version scheme, major, minor, patch version. That might be trivial. It also depends on the version control system is used. It's not always Git, although it's roughly 90%, but some customers still use all the CVS, Mercurial, something else. But when you find basically how to solve the first two, then it's pretty trivial. You just bump up the version, update source revision, and integrate it in your development workflow, be it either pull request or some other way. Yeah, I have a slide. That's how you do it with a dev tool. So you check the latest version of the recipe name, assuming that follows some kind of a versioning scheme. I think it checks, if in case of Git, I think it checks the list of tags, checking the current version of the recipe and what is accessible upstream. And then you try upgrade, or if you want to upgrade from the specific version to the specific version, not just to latest, and then fixing all the probably conflicts, wherever, and then you finish updating it. Those are the links how you do that. Those are basic commands, but maybe some other things you need some complex or specific stuff there. Yeah, Auto Upgrade Helper, like I mentioned, used mostly Open Embedded Core and Meta Open Embedded. It utilizes the previous workflow from the dev tool behind the scenes. And there's some documentation on how to use it, but again, I never seen anyone using it. I didn't try it myself. Okay, another approach would be, so how to solve the downsides of not using AUTOREV. You could have two versions of the recipes. Before I mentioned that dev upstream class was out of order, it probably should be somewhere here, but it was just convenient to have it with the EU dev recipe I had before. You can have a common part of the recipe in some include file. And then you can have two recipes. One is a fixed revision, which just includes everything common and sets source revision. And then you have a Git version setting at least the PV source revision to AUTOREV if you want to. So if you want the Git version. And the default preference -1. That means the fixed recipe version will always have higher priority than the one with the default preference -1. If you need that, then you enable it with the preferred version in your local conf or the other configuration snippet. So this preferred version depends on how you set the PV. that looks similar to what I described before with the dev upstream. So dev upstream seems like nice solution, but it has some drawbacks. So dev upstream does not support currently native or native SDK targets. And dev upstream class, I think it cannot handle implicit dependencies. For example, if you fetch something from SVN, the dev upstream class cannot know that. So in this solution, all the dependencies are set correctly. One bug we found also this morning, that if you do bit-bake layers show recipes, so those two, the fixed revision and the gate version, will be shown as available recipes. The bug we found with the upstream doesn't show that yet, but probably it will when it be fixed. Right, so that's how you handle several URLs. I mentioned like a bonus slide. You describe the source ref format, set particular names, and then you use the name argument in the source URI. And you set the source revision accordingly to each name of the repository. That's again an example of the existing recipe in the, I think, in the meta file system layer. So, what are some takeaways? Should we use or not use AUTOREV? Sometimes, like I said, it may come in handy, especially in the integration pipelines when you want to test the latest and greatest changes, but do not use in the release branches. I also don't think in the main branch it should be enabled by default, because it can lead to a lot of confusion during the development when several people work on the same Yocto project and they are not sure whether they build the same or not. So simply just don't use it and enable it only for your testing integration pipeline. What can also be one drawback here is that check that dependencies are set correctly, because that can also lead to build time increase a lot. Right, and if you need again AUTOREV, so having two versions of recipe for now seems like a good approach to me. Maybe if you know better, just let me know. Those are links again to ones which maybe included already in the other slides. And thanks Ayub, Alexander, Ross, and Richard for their review and all the valuable comments I have. Then, if you have any questions, feedback, complaints.
So, what I like to do with release, I like to have an offline build. Okay, so no state and all the sources locally somewhere.
Yeah.
And if you use AUTOREV there with whatever tricks you showed, I think it's not going to work, because it will go out somewhere to the network and try to pull in something. But he has to check the.
I think there was a link on that on a FAQ to Yocto where it's described how to use BB cache policy, BB source ref policy cached, and if you combine it with the allowed network, it might work, but I don't know. So I would also advise don't use it, especially in the release build.
Yeah.
You're making my life miserable.
Yeah, the source rev cache, BB source rev cache policy or something. You just tell it to cache always, and it will just remember the previous revs for offline builds.
What that means, you have to have a cache.
Don't talk to the hand, talk to the mic.
Yeah. But that means you need to have something in the cache. So
yeah, so it's not going to be the
fully
first
fresh
build,
offline build.
You need to distribute that file. I can't remember how it
More questions? Yeah.
You have mentioned that with auto revision, it will check automatically. Then the do fetch no stamp, it will not affect that. Because normally I have
That's a good question. I haven't checked that with the no stamp. Yeah.
The second maybe question regarding having two recipe. What about having BB append, which have auto revision inside?
But BB appends to the current recipe, so it's not another version. It's the same recipe.
Only in the Git, if it's only Git versioned.
I don't think it changes anything. So BB append is to the current recipes. If you only have BB append, it might make sense to use that dev upstream class. So then you have one recipe which essentially be two versions.
I have one Git, and it is building the recipe version, and with BB append, it's not related. It's you can set the tag inside the original recipe, and BB you can set the auto revision.
No, it will still override it.
Override.
It's BB append. It will override it. It's not another revision.
Okay.
More questions, thoughts, praise, marriage proposals?
I have maybe something not directly related, but normally when I, in the URL, define only the tag in the Git repo, I get a problem. It asks always master branch. And in the documentation, it is written you can define only the tag, but I don't know.
The problem is the tag can move, so you cannot trust the tag.
So it shouldn't, but it can. That's why usually you specify the hash or the source revision.
Okay, then if with tag, you need always the related branch.
No, you can have no branch option. But I don't think that has anything to do with AUTOREV, no?
No. It's, he asked if some thought.
You can have no branch option, but I would need to check whether it's
no branch
work.
option. I have it. Okay.
This silence is intimidating, right? Should we try and run away? Seems so. If there are no more questions, we will thank Slava and
thank you very much for your attention.
And let him run away from the silence. And I think we're back in 12.5 minutes for Leon. Or is it Anna already? Leon. Okay. See you there.
Photoshop him, and Megan can hire somebody to Photoshop it in.
If you want to have
Ja,
Okay, I'm gonna keep this to the schedule, even if there's some lazy slackers outside. Shut up. Perfect, that works. Being rude is not exactly allowed. It is not encouraged, but I do it anyways. Welcome back. We're on time for Leon, who will talk about AB update solutions. He's been a long-term friend and contributor to some of the things that I do. And I want to make clear that I did not bribe him, except with chocolates and beer.
Thank you very much, everyone, for joining this talk. Yeah, we're going to do a side-by-side comparison of dual AB update solutions, or at least some of the solutions that I am kind of familiar with. My name is Anavi. I work for a company called Kunsuku Group. It's a company specialized in open source solutions, specifically for embedded Linux devices. I have numerous contributions to Yocto project and Open Embedded, so it's great to be here with you. How many of you are actually contributing upstream? All right. Okay, pretty much all of you. That's fantastic. So I work remotely from Plovdiv, Bulgaria. Actually, in the previous slide, the photo was from my hometown. The agenda for this talk is relatively short. We're gonna have a look at the things available for doing updates. After that, we're gonna focus on 3 popular open source solutions, starting with Mender, moving on to Rauk, and SW Update. I'll try to do some side-by-side comparison. And finally, of course, we'll wrap it up with conclusions. So let's start with an overview of what's available as strategies. As you know, this has been a hot topic for the past decade. There have been so many talks saying what is the right way to do software updates. I'm not sure there is a right way. There are several different strategies that you can apply, and you can combine them. So the first one is pretty straightforward, AB updates. Obviously, you have 2 identical partitions of the root FS, and you are switching between them on an update. The second one is the so-called delta updates. Basically, these are binary diffs of the file system. I think the simplest, fastest way to explain this is to imagine something like Git for file systems. And we have container-based solutions and updates. Outside of the embedded Linux, obviously, containers are widely popular, and a lot of people are trying to drag them in, and the workflows that they have on embedded devices and embedded Linux devices nowadays are not so constrained. There are some really powerful embedded devices, so containers are a viable strategy and totally makes sense. Based on my experience, however, in real world, what happens is that depending on the requirements for the different device, we have to combine these strategies. So nowadays, we end up quite often with a combined strategy that picks the best things from these available options. So a little bit more details about the AB updates. Obviously, this talk is going to be focused on AB updates. We have, as I mentioned, 2 identical partitions which are changed and updated. However, we need to keep some information persistent across updates. That's why we need a data partition. And we need some kind of a application in the user space that performs the update. So we have to compile this application, have it part of our image, and different open source solutions, of course, provide this. When a new version is available, an update has to be performed. This could be done automatically, it could be done manually, but basically what happens is that you need to reboot the device so that the bootloader can switch the partition, and if everything is okay, to start working with the the new version that has been deployed, and if things don't work out, to switch back, to roll back to the previous known good version, which in the AB update world means to the previously active partition. So the Delta updates, as I said, it's like a binary diff of the file system. The advantage here is that you have smaller chunks of information, and you provide the device just the difference between the two images. Sometimes this could be a really, really small difference. For example, if you have changed a few configuration files in the root.fs, obviously it's going to be a small binary difference. It saves storage because of this, both in terms of space and both in terms of bandwidth, because the update artifacts are smaller. It supports rollback of the system to a previous state. In general, these solutions support that, of course. However, you have basically in the standard solution based on such kind of a Delta updates, you have one partition. So if something really bad happens with the partition, you don't have, like in the AB updates, an option to roll back to the B partition. Let's have a side-by-side comparison of these two strategies. We're not speaking about the practical implementation, but rather the strategies here. So we have the AB updates. They take more space because you have two identical partitions. The updates is larger because you have to download pretty much the whole root file system and to install it. They support rollback to a previous stage. Actually, the Delta updates also support them. However, the advantage here is that you always have one partition that's known to be good, and you can always roll back to this partition. Still, if the hardware goes bad, that's another story if you have these partitions on the same hardware. So yeah, these are the two advantages, and these are the advantages of the Delta updates. Basically, they're smaller. So this is a short list of popular open source solutions. There are a lot of solutions out there. I have delivered over the years several talks related to software updates. And before this talk, I sit down and had a look what's available, what's the status. Probably I'm missing some. Sorry about that if I've missed something that you're using. Actually, is there anything that is being used by someone here and I missed it on the list? Anyone? Okay. So these three things are something that you've got something that you're using and not on the list, or? Proprietary stuff. Okay. Well,
I'm coming. I'm coming.
Now is the time. Now is the right time to do a proper product pitch if it's an open source solution.
There was another talk about space at OSSU, and they talked about recompiling on the field because they are on a satellite.
Okay. All right. Yeah, I didn't mention it, but of course, complete reinstallation of the device is also an update strategy. Or if you have the budget, you can just throw away the device and buy a new device. But yeah, it's kind of expensive.
But that's not an over-the-air update, that's a through-the-air update.
Yeah. But somehow air is involved in all these ways, as long as it's not in space. I'll focus in the next of the slides. I'm going to focus on Mender, Rauk, and SW update, but there are a lot of other solutions. Some of them are based on containers such as Balena.io. Some of them are based on Delta updates. Actually, the majority, some of the things that you see here are services such as QB.io, as it can work with different underlying open source solutions for updates. Others, like libOS3, are again a backbone technology that's being used in several other solutions for software updates, such as in the past Actualizer, nowadays Actualizer Lite. Qt-OTA, as far as I know, also is based on libOS3, which was previously known as OS3, and Horizon. Horizon is a solution provided by Toradex for their boards. Some services didn't make it. There were really some services and solutions. There were really good options out there. I was particularly personally involved with here OTA Connect, which back in the day was initially developed by a German startup company, ATS Advanced Telematic Systems. Konsuku Group was under a contract with ATS Advanced Telematic System, and we helped them develop the meta updater layer and a tool called Actualizer, which was doing updates, delta updates based on libOS3. Initially, the project was called OS3, but after several years they renamed, and now I think they want to be called libOS3. So it was a success story because ATS was acquired by HERE, but unfortunately after that HERE shut down the service. That's part of the game. Sometimes these services and solutions got terminated because it's always important to have a viable business plan to fund the development. Another service that, as far as I know, was based on libOS3 was Full Metal Update. At the moment, it's not reachable, and I have seen that for several years there are no contributions. So I consider it a terminated service as well. I don't know the details what happened there. So back on our AB updates, the side-by-side comparison that I did as part of preparation on this talk was primarily done on two hardware platforms. The first one, Raspberry Pi 5, because it's my favorite single board computer as a maker, and probably it is the most popular single board computer out there. However, it's not open source hardware, and an open source enthusiast, I like open source hardware. That's why I also bought a kit from my neighbors from Olimex. I'm living in Bulgaria, they're also living in Bulgaria, we're in the same town, and they made this kit with IMX 8 M+, and I was particularly interested in this thing because at Konsuku Group we have a lot of industrial customers using the platform IMX 8 M+. I wrote a couple of blog posts with the exact steps how to get started with Mender and Rauk on these devices. They're available on the website of Konsuku. I won't go into the exact steps now because I just want to focus on the side-by-side comparison, and I've got around 20 minutes left. Let's start with Mender. How many of you are familiar with Mender? Okay. So Mender is available as a free and open source solution, as well as a paid commercial enterprise plan. So you have the freedom to use the open source version, but also you can pay and use it as a service and get access to some of the advanced features. AB updates are part of the open source plan, and the proprietary, the enterprise plans also contain a proprietary solution for Delta updates, which is pretty good, but it's proprietary, therefore I won't talk about it here. The backend service of Mender is a really cool feature because this way you can have a turnkey solution and do end-to-end updates starting from your embedded device with integration with the Yocto project and going through the cloud where you can manage fleets of devices. Several programming languages are used to create the whole ecosystem around Menders, including C++, Go, Python, JavaScript. Recently, the Mender client was rewritten from Go to C++. There are a couple of really important Yocto layers, Meta Mender, and the other one is Meta Mender Community. Meta Mender Community is where the reference implementations for various popular single board computers and development boards are available. The source code is available in GitHub, and contributions are accepted as GitHub pull requests. Here is the list of the supported devices. For this comparison, I tried to use the latest long-term supported release, ScarpGov. So this is the list of the devices that are supported in ScarpGov. If you have a look for other LTS releases like Kirkstone, the list of supported devices will be slightly different. Anyone is welcome to contribute new boards to this list. So if you have a board and want to get Mender to work on it, please take the next steps, open GitHub pull request, and I think Josef will help you get this approved. So this is the Meta Mender community, a screenshot from GitHub, of course. This is how Mender works, and basically I'm going to show pretty much the same slide for a RAUC and SW update. It's pretty much a standard procedure with different implementation depending on what solution you use. You have to apply the update. After that, you need to reboot. That's where the bootloader is going to decide which partition to use. Basically, the idea is that you want to use the partition on which the new update has been installed. And if for one reason or another it didn't boot, the bootloader should roll back to the previously active partition, and you end up in your old system. So there is this rollback option. In order for Mender to work, there is a client that's running on the embedded device. As I mentioned, it was recently rewritten in C++. By default, the Mender client is running in the so-called managed mode, which means that it connects with the Mender infrastructure in the cloud. However, you also have the option to run it standalone. This means that you take full responsibility of how you're going to handle your updates. You can implement, for example, updates from a USB stick, or you can manually run a web server somewhere in your local area network and manually execute the Mender installation command. So something specific for Mender is, of course, that they have Mender classes that you have to inherit. And the MetaMender community layer is using CAS to provide reproducible builds for all these boards that are supported. As part of my porting efforts to add the Olimex IMX6 board, I had to create a CAS configuration file which contains basically these Mender-specific variables, which are part of the local.conf, or in this case, from the CAS configuration, YAML configuration. So in a nutshell, said very simplified, of course, but basically instead of using the, instead of creating your own WKS file, with kickstart file, you are using the Mender variables to define what kind of partitions you have, and the classes that are part of the Mender core layers generate the image for you. That's a bit specific, which means that you have to go to the Mender documentation if you're porting a new board. You have to get familiar with the variable names and then port the new board. When you do AB updates, you need a data partition, and the data partition is, again, something specific for Mender. I mean, specific in terms of variables. So this is the variable that says what is the size of the Mender data partition. This is a partition that remains persistent across updates, which means that every application that you have in the root FS has to write data to this partition if you want to make sure this data will survive the next update. And this is typical for any AB update solution. It's not Mender specific. It's just the variables here that I'm showing are specific for Mender. This is something that I have done, and it's interesting because you may need to put something on this data partition as part of the generation of your image, and yes, you can do it. So here is an example. Mender has add-ons which are Mender specific and are really cool add-ons because they can help you out in different situations. There is a remote terminal, file transfer, which basically allows you to both upload and download files. There's a port forwarding and a configure tool to apply configurations to your device from uniform interface. So Mender is providing this turnkey solution because they have the cloud platform with these add-ons so that you can not just manage the updates, but you can really manage your devices in so many different ways. As I mentioned, there are Delta updates, but this is a proprietary solution, closed source solution. It's available with the commercial plans. The tricky thing here is that you have to switch your rootfs to read-only mode in order to take advantage of this, and this could be tricky. However, you can just do it by adding read-only in your image. And if you have a really, really small image, you might be lucky and everything would work out. But based on my experience, when you have built a really complex image with the Yocto project and Open Embedded, after doing this, you have to, or doing this in your local.conf, you have to take the next steps and to make sure all the applications really start in read-only mode. Have you been in such situation? All right. The next solution is Rauk. How many of you are using Rauk? Okay, fair amount of people, even Josef. All right.
Of course,
Rauk,
why not?
Rauk is a lightweight update client. It does AB updates, but it has advanced features that I'm going to mention briefly after that. It supports various different scenarios of updating, so you can do an update over the air, you can do an update with a USB stick, you can do an update within a local network of an enterprise, pretty much everything. It provides all the tools that you need for the build system to create, inspect, and modify the bundles. Rauk works not only with the Yocto project. Actually, Mender also works with Debian, but since we're here for the Yocto project Dev Day, I'm focusing on Yocto. So yes, Mender works with Yocto and Debian. Rauk works also with Buildroot, but we care about Yocto. That's why I'm talking about the Yocto layers. And actually, not only with Buildroot, but with PDX-Dist. But once again, we're interested in Yocto. Here are the layers that we've got and the different bits that make Rauk what it is, including a Rauk Hogbit plugin, which Hogbit is an open source solution for management devices. So you can install locally a management system with a web interface. And this is a plugin to use Hogbit with Rauk. These are the steps how to integrate Rauk on your device. You have to select an appropriate bootloader. If your device supports U-boot, that's great, because U-boot is really flexible, and there are already a lot of examples that we have created how to use it. You have to enable SquashFS, X4 for the root file system, to make specific partitions. In this case, for Rauk, this means to either create your classes or just modify the Open Embedded Kickstarter file, which is actually straightforward. You just take the reference Kickstarter file that you've got there and add a second partition to duplicate the main rootfs. You have to configure the bootloader environment to create a script that switches between the A and the B partitions, and to create a certificate and a keyring for the Rauk's system configuration file. The data partition in Rauk is very flexible. You can have either one data partition or two different data partitions. So Rauk has this flexibility that allows you to create different options for the data partitions. There are a couple of advanced features that are really, really interesting. On a daily basis, I took advantage of the HTTP streaming. This allows you to directly download and install simultaneously a Rauk update bundle. In order for this to work, you need, however, a web server on the other side where the Rauk bundle is that supports HTTP streaming. And the other really, really cool feature of Rauk are the so-called adaptive updates. So here the focus is on AB updates, but as I mentioned, things are moving towards combined strategy, and adaptive updates are like Delta updates with this benefit that you can even skip some versions. So you just between the version that's running on your device and the new version that you have, the Rauk adaptive update allows you to skip, like if you your device is running version 1 and you have new version 4, you can skip the incremental update and just go to the next, to the latest version. This is really cool advanced feature of Rauk, the adaptive updates. Meta Rauk community is a layer that I have created 4 years ago, and it was moved to the Rauk GitHub organization in GitHub. So this is basically a layer that provides integrations for various boards. Here is a list of the supported boards. It runs with that runs with ScarpGov. We have Raspberry Pi, BeagleBone, x86, NXP, IMX6 and IMX8, Rockchip, and OWinner, known in the community as Sunxi devices. And the third solution that I would like to mention is SW Update. Are you using SW Update? Okay, this is a solution created by Stefano Babic. It's been around for a while, really good solution. Again, it was initially focused on AB updates. It's very flexible, but now supports incremental updates of binary images, or in other words, you can again do this binary diffs even with SW Update. So one of the conclusions that we have to say is that the advantages that you take of Delta updates now can be even used with these popular solutions that are well known for AB updates. They have these advanced features, all of the three that we've mentioned. SW Update is entirely open source. It supports Lua extensions, and of course it's compatible with the Yocto project and some other build distributions, build systems such as Buildroot. I saw that there is also experimental dep package and Debian integration. Here are the layers. So we have Meta SW Update, which is the core layer, and Meta SW Update boards is the layer with reference implementations for different boards. At the moment, the supported boards are BeagleBone Black, Raspberry Pi 5, and Wonderboard, and this is an Atmel board. And finally, let's do a couple of slides with side-by-side comparison. All of these three open source systems that we've discussed have AB updates. Actually, they also have Delta updates, with the remark that the Delta updates for Mender are a proprietary feature, part of the commercial plans. And it's, well, the different solutions have different approach to these Delta updates, but yeah, they're available one way or another as an advanced feature. All of these three solutions support rollback mechanism. Mender has several additional features, and a really cool feature of SW Update is that actually there is a local interface, so that you can even apply the update from a web browser. You can start a server in your local area network where the update artifact is hosted, and then you can load another web page from the embedded device that you are updating and tell him use this one, or actually, sorry, and actually upload it from your computer. So this is as an alternative from the server that works in your local environment. So it's a really cool feature. In terms of programming languages, Yocto support, I have to say that all of them support ScarpGov, and the reference implementations for various boards work with ScarpGov, so you can enjoy the latest and greatest long-term supported release. ScarpGov is going to be around here from some time until 2028. Mender comes with this management server, while for Rauk and SW Update, you have to use a third-party server or some kind of an in-house solution. Here is a list of some ideas for third-party management services. I used AWS IoT for a project, and QB.io is a really cool solution if you are using especially Rauk and SW Update. Eclipse Hawkbit is an open source solution that you can have in mind. We talked about the differences between these projects and what make them unique, but there are a lot of common parts. One of these parts is libuboot Anavi, and this is basically the tool that allows you from Linux user space to access U-boot configurations, really convenient tool. A huge thanks to Stefano Babic, the author of SW Update. He's also the author of this too. Without this too, AB updates will be extremely hard. You need to know which is the active partition, and you need to communicate with the bootloader. I'm a little bit ahead of time, but just to mention that you can also apply combined strategies with containers thanks to layers such as meta-virtualization. And let's wrap it up with some conclusions. Obviously, as you have seen, there are several open source solutions. Each one of them is very mature, and in my opinion, there is no reason not to use them. Pick the one that suits you best. Don't do an in-house solution, because there are open source solutions. You can contribute upstream, take the advantage of the features that other people also contribute upstream. The dual AB update mechanism, no matter which solution you pick up, depends on the bootloader, because the bootloader switches between these partitions. Mender, Rauk, and SW update, all of them handle really well AB updates and do the rollback if needed. They have differences in implementations. You need to have a data partition to store persistent data across updates, and these solutions support, of course, this. I think Mender is ahead of game because it provides an end-to-end solution. It's probably not the solution for every case out there, but you have a management server integrated, so if you're looking a quick way to go to market, Mender provides you all the features together. For Rauk and SW update, you have to use either a third-party management server or to build your own. And Delta updates are part of these solutions nowadays. Sometimes they're called incremental updates, sometimes adaptive updates, but one way or another they come in. Thank you very much for your time. Here are a few useful links.
Leon, thanks a lot. I apologize for one thing. I just looked at the schedule, and you are the only one where I messed it up, and I gave you just a 30-minute slot instead of a 30 minute. That was unintentional. So I actually thought everybody had gotten a 40-minute slot.
No worries.
Seriously. So
no worries. I took 32 minutes.
Yeah. So I don't want to cut your coffee break short because it's late. Everybody needs some physical input. But I encourage you, take the time to talk to Leon, figure out all of your stuff, and personal opinion, use whatever suits your bill, but don't build it yourself. That's the only thing. With that, I think it's time for coffee.
All right. If you have any questions, please come around.
Welcome back, everybody, for the final stretch of actual meaningful content. A little bit of organization, like 10 seconds. Anna, also long-term friend, collaborator, partner in crime of mine, will tell you about building crazy things with Yocto that are not so crazy as it might seem. After that, I will have the final slot. So, I've been informed that the wardrobe people want to stop at 5 downstairs. I shall warn you that I do not really have a well thought out plan, and I do not have real content. I just have chocolates and booze and a couple of stupid ideas. You are totally excused if you want to run away early, grab your stuff or whatever. I mean, this is basically like the segue into party. Feel free to join with me, but you don't have to, okay? You have been warned that it might end up stupid. I took 1 minute of your time, and you are allowed to take whatever amount of time you want from me, okay?
Sure.
Thanks.
That's great. Okay, let's start. I hope you all hear me. Is the microphone on? Let's test it. Is it better? Okay, great. Then let's start. I want to talk about Yocto on the edge and my unusual challenges when I build a not so embedded system. I have actually a real life project I talk about here, and it's great I'm allowed to talk about this and also say which product and all the stuff. So first, thanks to Safer Cities and Chris that I'm allowed to talk about. And something about me. I'm Anna. I'm an embedded system developer at Innovax. We do consulting and contracting work from embedded up to the cloud and AI. I have a background in in embedded systems and also studied electrical engineering as a hobby. I just finished my last exam 2 weeks ago, so hopefully this project is finished too soon. And yeah, I'm basically doing all this embedded stuff, embedded Linux, kernel development, lots of Yocto, and I really like Yocto. And now some words of warning in front. Everything I tell right now is still based on Kirkstone. Yeah, we plan to upgrade the project, but not for before the release. And any bugs you find in my slides are based on this little distraction ninja. She comes to me for eating and distracted me while doing the slides. So all blame on her. And yeah, let's start with the vGrid project, the vGrid gateway platform, and the project and its requirements. First, a bit about Safer Cities and vGrid. Safer Cities is a New Zealand-based company building this vGrid gateway for security cameras, vendor independent. And the idea is they started with Balina as a platform for their containers running the actual software and want to switch to Yocto with Menda as an update system to get a full platform control for the system because of their security requirements. They really have high security requirements and want to do this really right and put a lot of effort in this. So they can update and control containers, the systems, and really fulfill all the security requirements they have and really have the control about it. And another thing I would talk some sentence to start is about working with the Intel x86 platform, the workflows, debugging, and provisioning. I'm young, I'm not sure if that targets anyone but me, but in my professional career, I never worked with Intel as a platform, target platform. I'm a completely ARM person, and working with Intel made me some headache because things are different. On ARM, where I have debug interfaces accessible, like UART, JTAG, and all the other nice stuff. Intel, I didn't find anything on the board, but I found USB and HDMI, so at least I was able to use keyboard, display, and the screen capture tools. Where there are SD cards and eMMC for memory. It's more USB and SSD in the Intel world. But on the other side, where you have to figure out which jumper you have to set in which way for flashing your storage in the ARM world. The Intel world is, I think, a bit like your desktop computer. And the way is more like create a self-installing image and flash from USB. So in all, I learned the ARM platform is so much more diverse and strange, but so much more familiar to me. And Intel is basically simple. But for me, it's really limited, and I really miss the debug options. But so far for this. And a bit more about this provisioning. This really made me some headache, because documentation on how flashing Intel is not that great. I think the best resource on this creating self-installing USB drives was this article by Good Penguin. It's basically correct, it works, but not for me. And to tell you why, we can have a look on the usual workflow, how things are put together in Yocto. I hope you can see and read this in the back. If not, the slides are available in the schedule. Just have a look there. Basically, you have different stages in the Yocto build. You have temporary work dir, the image deploy dir, where things are put together while still in work. You have the deploy dir image, where the things go if they're ready to be deployed and installed. And from there, you have two things that are used by WIG, for example, to actually flash and use the things. There's, for example, the rootfs, which is controlled by the WIG rootfs plugin. And everything that goes into the boot partition is controlled by this image boot files variable. And also used by WIG. And with this installer, the idea is a bit different. They just take the kernel and the rootfs from this intermediate location and write it to the boot image boot files. And the rootfs they build, is taken from the image deploy dir, fine so far. And it's an init rumfs with an init install efi. With this, I have 2 pain points. The first one is taking the kernel and the rootfs from the intermediate location. If you have a look there at the right side by image boot files, I added a little sentence from the documentation. Source files need to be located in deploy dir image. In some cases, it worked, taking it from the intermediate directory, but in others not. you may end up in a dependency loop if doing this. And yeah, it's not as it is intended. And the next one is this init install efi script. Why? Have a look at it. It basically does the whole partitioning again by hand instead of using Vig. And yeah, basically there are two locations where you put together your image. It's done by hand, it's really error prone, so just nope, I don't want that. And then I had a bit of headache to find a solution, and Josef helped me a bit with pointing me to just try it with multi-config. And the basic idea with this is separate the concerns and create distinct multi-configurations, one for the image build and one for the installer. So the image build is completely done and finished in its own environment, and the actual image I would flash to a USB stick or whatever for use it like it is copied to the installer, to the image deploy the image of the installer and put there together in this installer with a custom init install efi mender script. It's a bit inspired from the mender script, but you can do whatever you want. But the basic idea with the mender style is just DD the image you put in there as you would do it directly with the USB stick and the actual image. And a really nice point with this is you can use both parts separated. So the installer is standalone, the images are standalone, there's no cross-contamination. It's really a better idea than this other thing. And a bit more for reference, because I think no one can read it in the back anyway. If you want to have a look in how it's done, you can have a deeper look on the slides afterwards. And also on this. A little thing on this, I'm using CAS in my projects, I really like it. But there's one thing to keep attention at. When using multi-config approach, the local conf header thing in CAS is basically useless. Don't put anything in there. This goes to the actual configs for the different builds. And let's go to the actual things that were a bit fun with building this not so embedded system. Usually when building such embedded systems and the customers want login users, I really try to avoid this like hell. But in this situation, a user that's allowed to log in is actually fine and makes sense for the use case. But we have a read-only rootfs, we have AB updates, and we need login users, and we need this secure. There are some issues with it. For example, as said, the user needs to log in, but we have this AB partitioning scheme. Anytime we update the root partition, also the password and the user file is updated, but the file is read-only. We want the verity on top of it, so modifying is basically not possible at all. And we care about general security. So how can we solve that? Yeah, basically, what strategy do we want to allow the user to log in? We could create a password per device when building the image, or we can go with enforcing password change. building a device per image is, from my point of view, not the best approach in this way, because it makes a lot of work and doesn't give that much plus in security. But enforcing the password change was the thing we want to go with. But enforcing password change results in we need the etc password file writable. And this conflicts with basically everything else. So how can we do this? And the idea is pretty much simple and simple to use. We created a volatile bind for the whole etc directory because we don't only have password changes we want to overlay and to have writable, we also have configuration changes, for example, in the network, and created a bind mount this way with an encrypted data partition as a target. And this turned out working really well, and for us, really good solution. So let's have a look at this. Yeah, it's basically pretty simple. It's just a recipe saying, yeah, we want to have a volatile bind. You want to overlay etc with data /config, for example, and make sure this directory exists in the target. This volatile binds is not the only possibility to do something like this. There are other ones. For example, overlay fs.bbclass and overlay fs etc bbclass. Slava is just gone, and yeah, you can find his slides on this topic linked there. I would say just asking him about it, but it's a bit too late for that. But yeah, it works really well, and we decided for the volatile binds because it turned out working a bit better for us than the other options. And changing the password, enforcing the password change. With this AP updates, there's a little trick in this, because if we have this enforcement in every image, the user would update and would be enforced to change its password again. So we have built two configurations. One for provisioning with this enforcement, this change command applied, and one without for updates. So the user is only forced once to change the update and not every time. Also works really nice. And now to the encrypted data. As said, if we want to have this password changed in the etc files on an encrypted partition, we need to encrypt the partition, of course. And it's actually a bit tricky to do this in Kirkstone, but it's really clean and possible with looks2, TPM, and systemd. Nice thing on this, with Intel, TPM is basically just there. There are no different implementations of the trusted execution environment, as we already saw today with ARM. So this is a bit simpler. And the idea we implemented is like this. We don't encrypt in advance, but on runtime, because this also allows the whole thing could be enrolled afterwards. So we could, we didn't, but we could have done shipping unencrypted systems and encrypt them with an update. And the basic idea behind is having a system service which triggers and controls the encryption running before the data.mount mount point with a looks encryption script in there which starts the encryption in the first step by writing the encryption headers and actually running the encryption afterwards. This allows encrypting an already existing partition while the data is left as it is. And afterwards, we can link the TPM to the LUX device with system decrypt enroll. This is really helpful script because TPM is really a bit hard to work with, and the system decrypt enroll does a lot of work. And with these things, we have two parts left to prepare in the actual rootfs image. One thing is modifying the f-stub. So instead of the UID of the device, we need to add the mapper device. And we needed to add a crypt tab, which actually triggers the decryption of the partition. 2 notes on this. F-step is also modified by Manda in a rootfs post-process command. This is really a pain to override. And cryptab is actually pretty cool because systemd has a systemd crypt setup service where this is translated to by a generator on in front of the boot. So the crypt tab actually translates to an early boot action, and there's no need to write an early boot action yourself. Just the crypt tab is fine. But how to deal with this Manda issue in there? And generally, one discourse in dealing with limits in Yocto. There's always this thing how to deal with the situation you have to patch BB classes, ink files, or similar in Yocto. And in these situations, I had, I think, 2 or 3 of them in this whole project. I ended up with this solution, utilizing CAS. I think it's pretty unknown. CAS has a patch feature, and it allows me to apply really short patches using CAS on top of the repos and the layers without touching the layers itself. So I can really keep close on the layers. And this was really a game changer for me. So some words on why and when I'm using this mechanism. I find it really helpful for patching these unpatchable things. In situations when copying the file to my own layer doesn't make sense to me, because, for example, I just want to patch one line and don't want to keep track of the file mainline, don't want to copy it, and don't want I don't want to miss updates from upstream. And it's also helpful if everything else just doesn't work. But it's not actually Yocto by book, but it's really clean and maintainable from my point of view. And remember, it's not a replacement for BB append at all, but it helps with the files. Patching is otherwise a bit of pain. But yeah, back to the encrypted data partition part. For the encryption, it's needed to install the usual things for it. Have the package configurations for some things right. And there's an issue with systemd in Kirkstone. The needed libraries are actually there, but not installed. So it's needed to patch systemd, just as you see here. the good news, it's fixed in ScarfGap. And back to the encryption script. When encrypting such a disk, you actually need a password, even if you want to go with TPM for backup reasons or for something else. We generated just a random one using OpenSSL. We do this crypt setup, re-encrypt, encrypt task to write the headers. Do the actual encryption with crypt setup, re-encrypt, and afterwards enrolling and linking the TPM. Also a bit a funny bug or funny don't do it with the systemd version here. There's no command line parameter to pass the password in, but this debug thing with exporting a password variable, it's really not the best thing to do, but the only thing working with the systemd version here. And yeah, it works. Afterwards, this password is also stored to the disk and the device is rebooted. So we basically assume this is secure. And as long as you don't change the secure boot, the device just comes up and decrypts itself. Otherwise, it would ask the user for a password. But if this is the case, someone tried to manipulate the kernel in secure boot, and you can assume the device is tainted at all. And yeah, I talked about secure boot. Here it is. Secure boot with Mender is a bit a pain. I think secure boot is always a pain, but it's a bit better with Intel because you have one vendor, one implementation, and basically a good documented implementation instead of the ARM world, where you have to pay money to get information at all. But still, it's this complete book of black magic and witchcraft. If you can avoid it, go for it. But in this use case, it's actually needed to ensure the complete chain of trust is there. And otherwise, for example, team verity wouldn't be meaningful. What is secure boot? With secure boot, when you boot into UEFI, the BIOS, the UEFI loads the actual bootloader, the grub, and every other boot files you needed from this boot partition, this boot EFI partition, and you have signed files there. Then it goes to the TPM, checks the signatures. There are pre-enrolled there. We enroll our own ones, not Intel ones, not Microsoft ones, so we completely control the keys. And when the TPM says, okay, everything's fine, we can boot the kernel. Otherwise, there's a really shiny red error screen saying your device is not secure. It's tainted, go further. And to do this, we use MetaSecure Core, which gives us basically all the tools needed, patches for grub. It has the signing tasks for kernel, bootloader, and everything else. And it also does the TPM integration for keys and certificates and provides such a provisioning step in grub, such a single one-time boot entry for provisioning the certificates at the first start. But yeah, all examples, all documentation are based on initramfs, and this does not go that well together with Mender. And yeah, there's some pain points in getting it work. If you want to have a full read on some issues people had, and also I had, there's a really good discussion on the Mender forum. But to sum it up, I have the most important points here in the slides. Basically, it's quite simple if you have the right points. You have to install the right things, you have to define the right things, put the signed kernel in the right location. In this case, you have to put a signed kernel in this boot EFI partition. Only there it can verify it, but the kernel actually lives in the root partition with Mender. So the updating is a bit a thing. And there's another thing that needs to be done to have this booted. The Mender group entry, the Mender group configuration, per default searches on the root partition for the kernel. This needs to be changed to the boot partition to get this thing working in Kirkstone. If you have a look on the Mender forum with ScarfGap, there are new issues, and I think unsolved right now. So yeah, secure boot is always a bit fun. And really, it took a lot of time to get this working. And yeah, if it works, there's one thing left to do. As said, the kernel image and the signed kernel image need to go to this boot EFI partition, but this is not updated by Mender per default, just the root partitions. But Mender is this neat state script mechanism where you can hook up the boot, not the boot, the update mechanism, and you can enhance it to also update the kernel in this boot EFI partition. I did this with executing enter and leave actions in front, not in front, after, and after the artifact install and the artifact rollback action. And this really does the trick. You should test this really well, because if the kernel is broken, it's a bit an issue. But yeah, you can do the whole thing with it and make sure everything works fine. And now in the end, we built, hopefully, I think so, a really solid and secure system. I showed some of the security mechanisms and challenges we had, not all. For this, I would probably need a whole day. And we have ended up with really clean and understandable code, I think, with doing these tricks, for example, like this cast patch mechanism. But it really takes some time to bring pieces together, for example, the secure boot thing. But I think the result is really worth it. So, thanks for your time. Thanks for attending here. And time for questions. So, wait for Josef.
Okay. So there's a lot of signing going on. How do you manage the keys in a secure way? I mean, it's one thing to set this up once, but in a repeatable way and
yes, managing the keys is really a large issue with that. I didn't talk about it in detail because it is really a thing, and it's not done by me. the Safer Cities guys are really good in such things. They have a whole certificate management software thing, key store set up. They have a root certificate, I think, and branch up from that for several reasons, so they really took care of that.
So when you lock the board, so you have a secure boot, can you still, for example, boot it from the USB when the USB would have a secured signed kernel and do some, for example, recovery in, for example, the whole SSD dies?
Yes. With secure boot, yes. And in the Intel world, you can reset the whole key thing in the UEFI. There's a task for that, so the whole device is basically cleared. Everything installed is cleared, but you can reset up it.
Okay.
That's a bit nicer than in this completely locked and burned ARM world.
Okay, thank you.
More questions, thoughts, ideas, whatever's? Doesn't think so? Well then, thanks, Anna. I have like one hopefully final announcement. Is Megan back already? Too bad, right? Before everybody runs away, can we gather the speakers for a group photo? Slava has already left, but I think we can manage that. And yeah, in about 5 minutes time, feel free to join me for chocolates, booze, and group therapy. And we'll see what happens.
I really searched long for
Megan,
finding something that fits my needs. And yeah, there is no documentation. I found it in the description of a cast file, there's patch mechanism, how does it work, and I looked for it in the code and actually the test files. Yeah, but it's really a game changer for me.
First time I see that. Now I go to the restroom and I want one of these two.
Yeah, it's basically not there, but it would be so helpful if it was.
I know her, but I don't think.
More.
Oh my god.
I hope so.
Then I'm okay.
It's really easy.
Okay. I actually know you're deferral, dude. Yeah. Okay, but yeah. Restroom. Yeah. Food. Photo. At some point in time. I'm confused. Okay, I don't crash out of my. I'm just being big now. I go in there, then I'm just making really bad example.
You're stressed out, right? Great. Everything's awesome, man. I'm excited about it.
Okay, okay. No, then I'm good. Okay, this was the keyword. Okay, this. But actually, exactly that. Exactly. That. Yeah, then I actually, no, I'm yeah, I'm gonna try to do some further. And then I do something and the balance and then. Okay. Speaker photo?
I mean, we normally take a whole group photo as well.
I have a couple of group photos.
I'm not in it. So what group is that?
Nope. 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 Yes. Okay. Welcome, or happy to still have you. Oh. Good point. To the probably worst prepared session that has ever made it to a Yocto project summit, because I actually have no clue what will happen in the next 5 minutes. Housekeeping for this session. Mender has been mentioned a couple of times. I'm not going to talk about updates now. I just want to say they pay me and they love you. That's why they give me money to buy chocolates and booze for you and stickers and stuff. It is in the front row. I encourage everybody to just leave their laptops back there. Join me for a little party here in the front. Have a chocolate, have a drink, grab some stickers. If you put the stickers on fancy things and take photos of them, I can buy even more booze for you. Isn't this how marketing works? You give people booze? Okay, somebody gave me booze. Okay. Yeah, very good. No, and with that, welcome to the first time that I'm doing actual live coding live in front of living people. The original plan was that I round up a dude who has actual experience in the Python world, so we can do some packaging of Python stuff right here on stage. Turns out that said dude unfortunately couldn't make it, so I tried to figure it out how to present it myself. Turns out I don't have a clue about Python. So I talked to somebody around here and said, like, I would like to package some Python. And he was like, hey, easy. There is this one package that I always use if I want to demo this. So, I'm set. I prepared a Yocto build, really standard stuff. Yeah, speak up.
Do you have a laptop here? Since you have a ARM laptop?
Yeah.
Could you elaborate on the laptop you're using? I see very weird things like ARM64, but also an Apple.
Yeah, that's a MacBook Pro.
Ah, okay. So, but it's Ubuntu?
It's in parallels. I'm just using a virtual machine so I can build stuff. Very good. Hey,
thanks.
Somebody who is actually looking at things that I do. That's crazy. So, yeah, okay, build setup. I have a Ubuntu machine that I did the standard quick start build for ScottCup. I added Meta Open Embedded. I added Meta Python. I added systemd just so it feels somewhat familiar to me. And just to prove that, that it actually works, I'm going to give you a quick boot. And funnily again, it's QEMU ARM64 for no good reason. It just feels familiar to me to do something like that. I'm going to shut it down right now. You're the craziest bunch that I've presented in the last couple of years, because usually when I say I have free booze, everybody comes jumping at me. Seriously, what's wrong with you people? Okay, while this shuts down, I'm going to pour you some.
That should happen after fifth drink.
The plan is just to make this place stinky.
To avoid spoiling it, can you think possible?
Josef, I feel back in high school.
Yeah, that's how it works. Okay, just pass them out somewhere. I feel so.
Just give it.
You want the bottle, right?
Yeah, please.
Just.
Was ist denn das?
Das ist der gute Stoff.
Wieso tust du so wenig reden?
What if the conference security people come?
that just happens if it's the two of us. Okay, let's go back to actual coding. So, dude said to me, just use a thing that's called GPI 0 and smash DevTool upon it. Like, okay, that actually sounds like I could do that. So I looked where the repository is, github.com. I can memorize it. GPI 0. So their sources, it says it's something GPIO, it's something Raspberry Pi, and it's something Python. So I thought it fits the bill. I took it, and then I said, DevTool. I can't remember what DevTool does, so DevTool. And I was like, okay, what will probably give me a new recipe? It says add. Okay, DevTool, add. Oh, what could I possibly use? DevTool, oh, and it's not that pretty to read, but I guess that, okay, a recipe name and a source tree. I'm just trying it. Okay, it's called GPI 0. GPI 0. I'm just typing. And because I don't know any better, I just was like, okay, I'm gonna try with this URL. Let's see what happens. Go ahead and find out. And DevTool runs off and looks at it. And that's like, smash. Yeah, it's live coding. Here it is. Thank you. I also have chocolates for those who do not drink. And it says, okay. Source tree is build directory. Might do the recipe. Look at the code. Okay. Let's look at the code. Build. We're in build. Workspace. Recipes. GPO 0. GPO 0. And turned out it actually has understood that this is a Python package. It successfully inherited setup tools. And this was the part where I was really surprised. Usually, if you do things, then it says like, it probably looks like this, but I don't get the dependencies. I really have no clue what you're doing. And I look at this and it's like, okay, this has like carved out 10 dependencies. It doesn't sound too bad. Plus, it is actually like only 10 lines of payload. That looks awfully close to being real functional. So, okay. Let's just give it a try. So, bit big. No? I see some discussion coming up. That's good. That's good. Actually, fun fact. I've used DevTool quite a bit in the past. You know, what the one missing thing is in DevTool? Clean. You can do DevTool build, DevTool deploy, all of those fancy things, and it should feel like home to you if you're using an SDK and an ESDK. But the ESDK does not export bitbake directly. So there is no clean. No, that cleans the recipe. But if I'm working on code with a broken build process, or I'm doing application iterations, then it would be so nice to have DevTool clean and then reiterate. Story from my life. This is actually the only patch I've ever tried to submit, and it fell through the cracks somewhere. So I still have no patch in Yocto anywhere. So it did build. Probably we should try to install it. This is as far as I got in the preparations. We're on completely uncharted territory now. So conf local. Yeah, but the target is not running. DevTool deploy target if I had a connection somewhere, but it is not there. Plus, I don't have a Raspberry Pi, and that's also where I was like, okay, the guy who said I should use this library, he was well-meaning because he gave me a library that actually works. but he gave me a library that I can present. So yeah, we're in this together. I can rebuild the image, put back core image base, because that was the one I just started out with.
You could also deploy to QEMU.
I could, but it would need to be running.
You can start.
Possibly. Which is true. Like I said, I'm completely unprepared because of things happening this week, starting out with flooding and other presentations and buffs and other conferences and a lot of beers in between. And that's why, like I said, this is group therapy, or it is my therapy. I don't care. And that's why I warned you. You're allowed to leave. You're also allowed to do other things. And usually during my live coding sessions, I do one thing until it breaks, and then I try to find something else that we can do. So we are building now. Hopefully we have an image real soon that will hopefully contain this Python thing. And this is the part in my live coding where you usually be like, okay, and what shall we do? Yeah, you have got an idea?
Yes, of course.
Ah, perfect. I know I can trust you.
Just make a layer, and with dev to finish, you move it there and see if it still pings.
It's nice to have an external brain like you, because I actually have prepared a layer and I forgot about it. Awesome. Yeah, let's do this. Okay, let's just build it. Let's see if it's there. Leon can hopefully tell me where I can check if GPI 0 is installed. Probably user share Python something. Oh. Ah, thanks. Yeah. It's getting always better. Okay, so we check first and then we boot. OE package util, package data util. That's a good one. Yeah, I always forget about that. Package. Oh, very cool. Very cool. List. Package. Files. And then GPI 0, right? Unless the split goes wrong somewhere. Just checking if there's no, it's just the library, right? Oh, okay. Pin out pin test. Oh, okay. Let's boot this up and see what happens if we run this. Run QEMU. No graphic. Okay. Root. Pin test. See, we're doing.
But it told us this already before. In the recipe.
It told us that it might possibly be missing.
In the recipe, if you look into it.
Yes.
Color 0 is mentioned.
Yep. I actually only remembered SpideF being possibly missing. Okay. Now we're doing things here. Okay. Power off. Color 0. The usual first place to go if something is missing, the layers, color 0. And I guess we're stuck right now. No, it's there. Color 0. Let's see. We're just trying. Okay. Where is the recipe? Actually, then it becomes questionable. There is a question back there. Can somebody please pass the mic? The question is, how did it get some of the dependencies but not that one?
It's color 0, not Python color 0.
Yeah. Okay. So in because the statement of the dependency is just color 0, it doesn't make the transition that it might be called Python 3. Oh, okay. Interesting. You
bet the other packages are Python 3 prefix as well.
Yeah. I don't know.
I do have a remark. This package is on PyP, and last year I upstreamed some patches so you can use devtool add with a PyP URL, and it will benefit of the PyP infrastructure. And actually, you will have this error depends on the package.
Let's try this.
Maybe that was your next move. So you should remove the first.
Dev tool add. I'm going to be creative here. Exactly. So Python 3, GPIO 0. How does a PyPy URL look like?
Just go on PyP and type GPIO 0, and you will have it.
GPIO 0.
Yeah, first link.
So I can install.
Yeah,
I can
you
just
copy past the URL.
Okay, awesome.
Different name.
It is a different name.
Yeah. And actually, it will be the default name will be prepared with Python 3 as you wrote it, using this URL.
Are you willing to bet on this?
Already in the workspace.
Obviously not.
Yeah, but because you already had one. But
yeah, but it is now called Python 3 GPIO 0. So obviously the logic is off somewhere. It happens. Let's see. Okay. No, workspace, recipes, Python 3. Inherit, PyPy setup.
So you have the air depends right now.
It has found more things.
Yes, and inherits PyP BB class.
So the last line is new with PyPy package.
That is an
I think that's because the name doesn't match the recipe name. And
that would have been my question now. What does that actually mean? What does the PyPy package thing?
Okay, this is because sometimes on PyP you have a read name with lowercase or uppercase, maybe dash. So this is a unified name. So the recipe will be Python 3 GPIO 0, but sometimes you have on PyP some real name, and your URL in PyP BB class is using this PyP package variable to fetch it.
Summary for future self. If I ever get confused about package names versus PyPy names, I look at this variable.
Yep.
Okay, I think I can memorize that. Thank you. You're my pair programmer now. Obviously, you got the job. Okay. Then let's put that one into the build. Like I said, I'm perfectly fine with giving everything a try.
Shouldn't it be a dependency of G?
What should be a dependency? No. Go ahead.
No, if this shouldn't be the dependency of the packages we were trying to get running first time.
It's the same one. It's the same. We're just replacing it with another URI.
Okay.
Different storage for the same one.
Okay.
Okay, let's see what happens.
Did you add it? No.
I added it. Can somebody please hold a microphone in front of Robert's mouth?
I'm just saying how dearly I don't love Python, because all these dependencies are actually resolved in runtime. Yeah. So in another programming language, in a different universe, all these could be resolved in build time actually, because we have already a list of what's needed somewhere. And there are actually tools which can do this, but that's then more challenging. I mean, you try to run something like you did, and
yeah, but that's because it's an interpreted language.
yes, but still you could in runtime already. I mean, because of the dependency lists you have in runtime, it just told you I'm missing that before already. You know what I mean?
But but given a strictly interpreted language, it doesn't know until it hits the import statement.
Yes, but we saw already, for example, this dependency is missing before we even ran it. We saw it also with running, but from the description, what are my dependencies, we see that this stuff, this zero thing was missing.
So you're saying that you're a pessimistic and Python is an optimistic. Because you say, I already know in advance that it will go bad, and Python says like, I'm just going to try, maybe it magically shows up.
Yes.
Oh, okay.
Well, actually you don't need it because the command I'm calling, it has to need it.
Maybe somebody else stored it.
Someone, and that would be the Android approach. Things appear magically. We've learned that at the Build Systems microconference. We don't know how to build a kernel. We just expect it to magically show up. Literally. Okay, where are we? I actually think Ross wanted to say something, but he's hiding in the back. Yeah, please give him a microphone. I only understood I have a patch.
Ship it.
Which is actually, which is not that exciting coming from your mouth.
Robert's right, Python's a pain with dynamic high depends, but I've got a patch that will extract the metadata from the Py projects and automatically add R depends for you. So if the package metadata in PyPy is correct, then you get magic hard depends, which should solve some of the problems.
I can't follow, but people are nodding in the front, which means it probably makes sense. Okay, anyways, we gotta boot it again. Pin, test. I mean, I'm okay with it not being locate Pi revision.
You're not running Pi test on a Raspberry Pi.
Okay. And I guess that is a fair statement.
It's a solution. You can set it to unlock the environment variable to still run.
Okay. You can read better than I do.
So it looks like we can just set the environment variable GPO0 pin factory. Maybe it runs.
Yeah, let's find out.
It seems like Klimuk has emulation support for Raspberry Pi as well, so you can emulate Raspberry Pi directly. I don't know how to do this, but that's fine. Yes.
It tells us something. Okay. Okay. Proceed with that. Hey, it says okay. It says testing okay. I hereby declare that we have created a new H code base because it has runtime testing and it says okay. I consider this a very successful wrap up of my presentation. And like I said, I'm kind of sorry for not being better prepared, but I hope you could enjoy a little bit of fooling around with me. And like I said, thanks everybody for being with us. Just let me be emotional for 1 second. Okay? Thanks everybody for being part of Yocto project and making this happen. We hope to see you around real soon. See you on the mailing list, see you on IRC. See you especially on Yocto project summit early December. And yeah, like I said, thanks. I hope you've had a good day, and Leon will now enlighten us with some additional real wisdom.
I just wanted to do some nitpicking.
Yes. That's okay.
Yes.
That's okay. You don't like my hat, right?
Can you show the recipe again?
I think I can. I think I can. Yeah. I can also give you chocolates. Oh, that's interesting.
You can use Control A, Control X to leave QEMU. So much faster.
Yeah, but that was faster. No, MacBooks also don't reboot that fast. Okay, Leon, recipe.
So you had this generated PyP package name, right? But
seems so.
But in this case, it's not needed because it's the same name as if you get rid of this line, the default will be the same value, and it's no point to have this line in there.
Okay, Ross, can we have a patch for that?
Actually, I did write this, and I had to use it to add it because we cannot know at this point if it is the same or not. And there is a statement saying that this is you have to edit this recipe to get it working. So at some point we add some variables that we don't know if they are mandatory or not, but you can remove it when you finish a recipe.
The logical consequence would be after stuff finishes, you compare the guess with the actual thing that you're seeing, and if they are equal, you don't write it in.
You can remove them, yeah.
Is this not related to AUH, where you can find the package on PyPy and see if there is an update maybe? Because based on the name of the recipe, we would know the name on PyPy.
I don't know. Alex probably knows things about AUH. I just know it mail bombs me.
So PyPy whole naming thing is a confusing mess, and they keep breaking it. So it's lowercase, uppercase, underscore, dash, this and that, and it keeps needing to be tweaked. So yes, we have defaults in PyP, and they sometimes work, and sometimes PyP changes things behind our backs, and they stop working. And then it needs to be tweaked. So I like that it's put explicitly in the recipe, because that way at least you know what it is by looking at the recipe.
I spent far too long staring at PEPs and discovered that there are standards, just that no one respects them. So when setup tools is fixed, everything should be consistent, but unfortunately people still use setup tools.
Were you at my rant yesterday? Yeah, because it was exactly that.
Oh, and by the way, when you add the new recipe, run devtool latest version on it, or I will tell you off.
Okay. By the way, Robert reminded us
that make sure that the latest version check works.
Zero. Meta. Vienna. Source is not clean.
You can use minus dash F.
And you shouldn't have the
force it.
The dots as well. Just the name of the recipe, the layer.
I will give this a try.
Dash F.
I just happen to know that I created the layer, but I did not add it. Okay, bitbake layers, add layer, meta, Vienna. At the moment, it's still in workspace.
Oh yeah, sorry.
Continuing as requested by force. That's a nice line. In a future life, I'm gonna be a sneaky error message writer. Fun fact, because this will take a couple of minutes. is there anybody in here old enough to know that there once was an operating system that was famous for having error messages in Latin? See, I can't memorize DevTool, but I can memorize stupid things. So, Multics, like one of the Unix predecessors, it was a very rare corner condition where the developer thought it would never, ever happen. And that's why he made a joke and entered the text for the error message in Latin. He went off. It took years. And at one point in time, they upgraded that machine on an installation. It didn't boot back up, and they just got this cryptic error message. They traced him down. They phoned him in the middle of the night, like 3:30, and asked, "What is this shit?" And he was like, "Huh? What?" And then he said, "Yeah, but please translate it." And the error message was today the tree has grown a second root. They were trying to boot the system, giving it 2 root partitions for whatever reason. And that is the mythical Latin error message. It's completely irrelevant, but it got me across the DevTool. Okay, it is. Robert, I think we can keep this in workspace, right?
It should have erased everything relevant there.
Yeah. Okay. So you say bitbake the recipe or the okay. Okay.
I mean the image of the recipe, whatever you like. It should reprint the recipe now.
Okay. Let's find out. Doesn't look too bad. Should we just like look at it again with OE package data user? No. Yeah, Python 3. Yeah, it doesn't look too bad, right?
You want to know if it comes from a layer, you can use bitbake layers, show recipes, I think.
Yep.
And you will see if it comes from a workspace or the layer. You can do that to find.
Show recipes? No, that one. Here it is. Grep GPIO 0. That should do the trick, hopefully. Minus N2 or so. What? But I'm not talking about bitbake layers. Okay. He said show layers. Show recipes, okay. PN spec, So that's the old name. Yeah, I was curious if it gives me both because it's a regex or if it just looks for exactly that one.
Wildcards allowed, so you can try that.
I should have been okay. Let's find out. No, see, I didn't need that quote. Not too bad. It's the interesting side effect. Who can spot it? Yeah, the one is good. The other one is not. Okay, other cool things we should do. Or should we stop?
Drinking.
I'm all in. You didn't grab one. There's the ones that I pulled us.
So you say the cloakroom is closing in 15 minutes? We should get
Aren't they kicking us out of the building at 5?
They're kicking us out.
You said that.
No, I said they closed the wardrobe.
Which is equivalent to telling people to leave, isn't it?
Not to me. Yeah, anyways, like I said, thanks for sharing the fun with me, and whatever, so nice.